digitalization which is coming, they are AI enabled, So everything is coming on your mobile, your hands, and, on AI based. So he told me that just go explore. Okay. He has just, pushed me in an ocean where I found that everybody is talking about digitalization nowadays. Everybody talks about AI, everybody talks about ML, but they doesn't know what is actual outcome which is required. So the first question which I asked from my team, from myself, and from all guys where I am presenting, you have to think that what we want to achieve. Anything which we are developing, is it really useful, or we are unnecessarily making few dashboards, hundreds of dashboards we are making nowadays, every department made a dashboard. But are we using that dashboard, or only for display we are doing that, right? So in digitalization, you develop anything which can reduce your cost, which can reduce your manpower, or human error, which we call in our industry, human error is, 70%, and rest all analytics, if you do, we'll find it 30%. So while doing an analysis, a very big question given to me is a challenge thrown by my mentor is, you have to develop a model for turbine vibration prediction, not a small pump. You have to go and just give me a model for steam turbine vibration prediction. So just come up with the challenges you are having in this particular modeling. So I went back, I did my exercise, and I came back and I told him that first thing, I don't know analytics. I am not a data scientist or a data analyst. Okay, next. Next, I told that I don't know what final outcome is required from this. What we are going to do after this prediction of steam turbine vibrations. Right? Because I am not an operation expert or a TG expert, something like MMD or mechanical maintenance, they are expert for this. So if I'll identify that vibration is about to come after 8 hours, what I will do? Right? Okay. Then immediately he told, okay, make a team. Take all those guys. Take one analyst. Take one mechanical expert who is very well known to these turbines. Take one guy who is very good into, operations. Make a team and just go ahead. Then while doing this, again, one problem came that, yes, we all are having OEM systems like Shinkawa, Bentley Nevada 3500, every one of us, we are working from years and years now. Are you able to decode the data which is supplied by Bentley Nevada or Shinkawa? No. So this was the big question which I asked, that, sir, it is in an encoded and encrypted form. I don't know how to decode it. Then he said, go to Shinkawa, ask to GE. I don't know. Whatever you need, take it and give me a model. That's it. I approached GE. I approached Shinkawa. Okay, I can give good names in India, those who are looking after these systems for years. And they themselves told me that we only know how to extract data and give it to the vibration analyst. Nothing more than that. Then the challenge is now more bigger, because the OEM experts, those who are looking for these systems for years now, they even don't know what is the encryption they have put. Right? So similarly, we have every resource as our plant, but we don't know how to utilize that, and we are totally based on, OEMs. So whenever we got stuck, we call OEM. Whatever he will say is a, true thing for us. He will meet to our seniors and he will say, I found this and this is the problem, but he will not give you analysis. So this is the problem which I faced, and I gone back that this is the problem. Then he said, now what? Then he used a term, I remember still. If in Word, nobody is doing it, okay, then you are free. And if in this Word, in any single plant, if it will be found, then you will be sacked. He has clearly told me that किधर भी अगर हुआ इस दुनिया में तो तू गया, और किधर भी नहीं होगा तो मैं तेरे को छोड़ देना है. So this is something. Then I explored more. Actually, this is a senior leadership push towards digitalization, actually, because it is a must thing to have. Because then we entered into a zone. I called my team and I started thinking out. I took those archived files from that system, and I applied something on that. I applied my mind that how it can be decoded, because it is a digital formation. So something we know. If we study, if we deep into this, and we entered and we found that we made a SQL query, because that is a SQL base. If you may have seen, the data goes into SQL. We made an SQL query and we successfully, decrypted and decoded the data of Shinkawa. Okay. And then we identify that each information is already available into the system, but from years and years, we are not using that because we are not inclined towards this type of thinking actually. All right. So suddenly we start thinking in a different direction now that all the informations are already there. Now, on top of that, I have to put some algorithm and some, algorithms to find out and extract the actual data which we require. And then we see, and then we develop. There is an indication 8 to 10 hours earlier, whenever this turbine is giving an indication of high vibration. There may be, many causes for that. So you have to make a model and you have to train for some abnormalities. Only required thing is data, So you have to identify this. So this is one example where you have to think very deep into this. If you will stuck somewhere and if you will stay there and you will say, no, this will not happen or this is not going to happen, I cannot build this model, then you will stuck. So by the same method, almost 12 models we did, almost 12 very good digitalization projects we did in span of very short 1.5 and 2 years. So if some of you were there in an O&M conference which we held at NPL, so that is the thing. So my request to all of you is the digitalization first point, which I always say is you must know the outcome which you require. Don't make anything which is, you will make it and throw it away. Right? You pour manpower, you pour some cost and everything you are putting, and then you put it aside. So these type of things are not digitalization in true sense. So it is only if you can give something, some outcome to company, some output to organization or even your department, which can give you a good analytics to save. It may be a very smart, analytical dashboard for your own department to reduce corrective maintenance. That can also be a very good digitalization tool actually. Okay, we try to reduce human error by scanning that barcode and getting the data and getting support from seniors on a mobile in a window. That is again a very good, digitalization tool because it will work as a helping tool while doing troubleshooting in critical situations when your boss is not there at your site, right? So you must have the outcome. Whenever I project any digitalization project, I always write the desired outcome. So that desired outcome is must for any project. Then only you schedule the project and then you complete. So hope to see very good digital projects done over all, industry. And I'm happy to be here. When I started that group, actually, that is one or more initiation I started, that I should call all those CNI head persons into a group and a WhatsApp group I made. Then I reached to some senior people like Khatri Saab and all. And I initiated that group and I asked them. Then some of them asked me, why this group? I told them every one of us is having, a unique characteristics or a talent. So if total talent of India is coming on one platform and if we are sharing all those problems and good practices, 60 to 70% problems of our plant will be solved within. Right. So I tried to make this conference at my place, but he always, like seniors are seniors, so he won. I am not able to take approval so quickly, but as he is on a senior position, I immediately took an approval and I started this. So thanks to you, sir. And thanks to you all to be present here, and hope very good projects we'll see and we'll implement this very soon and we'll meet next very quickly. Thank you. Thank you so much.
Thank you very much, sir. I'm sure everyone took away something from that. And keeping up with the learning, I would like to invite our head of plant, Mr. C.N. Singh, to address us. Welcome, sir.
Respected Jha Saab, Ujjwal, Manish, and my colleague Rawat Saab, and all professionals, or we say now the today digital workshop. Welcome to all here. We started, I still remember operating plants in 1981, we started. So we used to have big buttons, and half of the pressure we have to put on the buttons to operate. And big dials, putting set point rolling like this. And today, with a device like this, you can operate the plant. So that is the growth. I read a book long back, Elvin Toffler's Future Shock. The rate of change. Generation used to be earlier in 1950 years, then it came to 25 years, then to 5 years, I don't know. Now new generation products, industry 4 automation to next one, 4.1 and all are coming. So all we professionals has to have adaptability and a mind, a young mind to be young to adopt it. I normally divide total industry in 3 parts: people, processes, and assets. It's the people who create the process and keep the assets delivering. And I always say in my discussions on very, very general term for the layman, 2 things are objective of business: more from same and same from less. Total business. That's what the evolution is: time compression and resource compression, if you go in the management terms. But layman terms, more from same and same from less. Of course, these words are what my ex-CEOs used to say. So come to this AI, ML, IoT. See, today is the day of convergence of the technology. There's no more mechanical engineering exists, no more electrical engineering exists, no more instrumentation, communication, all are converged to a point. And we have to practice for our survival as a professional and industry survival in the next decade. And we have no option to adopt it. Coming to learning, we used to earlier, and still we say the best practices, learnings. But today's subject is, these are these learnings of the machine, operating parameters, any machine. It adopts itself. And earlier circuits, what used to design in a constant curve, given by the physics and professors or research, that this way airflow will behave, this way cold flow will behave, this way my turbine will behave, this way load will behave. But now, when first time we heard of the intelligent transmitters, so they were automatically acting by feeding some program based on the theories or empirical equation made by the designers. But today technology is that it has got the technology of digitization and the data we have and data we generate daily. It adopts itself by monitoring, learning from that to get the best way. Of course, we have started, world is already there. And I was telling yesterday when Katreji came to me, so I told her, read some annual reports of the companies, and they have declared savings of 300, 400, 200 crores. Opportunities of 500 crores in the business terms by adopting technology, innovation, using digitization as a tool, and machine learning as an environment, bringing everything to one platform. Today, the computing capabilities are unlimited. Communication capabilities has increased. Data computation and bringing out the results are very fast. We remember earlier when ACS we used to command, the cold flow increase after 1 minute. Sometimes say, "Saab, command jaane mein time lagta hai." So we have to adopt the technology. The language of this decade is, I don't say century, is digital, and machine learning coming on a platform where human error, human mind capabilities are challenged. We write the books, write articles, make the manuals, learnings. Now it's coming in itself, and we have to implement it. And I'll tell you, as Ujjwal was telling, that there's no proprietary thing today. Everything is free and open source. Only we have to break the barriers. A lot of products are available, but we have to create our own environment by rightly setting the objective, what we want from him, and we should go in phases. So my all best wishes for the workshop. People learn and create a better and better environment, better and better growth for the companies, themselves, a nation, and human race at a bigger part. Thank you very much.
Thank you very much, sir. It is said that only through the experience of what has been can one move to what will be. And who better to share the experience with us than our honorable chairman of JPL, Mr. Anil Jha. I would like to request sir to please come. Please welcome with a huge round of applause.
थैंक यू। सबसे पहले तो आप लोग ताली थोड़ा जोर से बजाइए। पावर प्लांट में काम करते हैं तो जोश दिखाई पड़ना चाहिए ना। और एक बार बजाइए। गुड। मेरी आवाज सबको साफ साफ सुनाई दे रही है? A very pleasant and warm good morning to all of you. Gentlemen on the dais, Shri C.N. Singh, Plant Head, Tamnar, Shri Avinash Ujjwal from JSW, Shri Munish Johri, Shri Gajendra Singh Rawat, participants from various other institutions and organizations, participants from JPL, ladies and gentlemen. I, on my behalf and on behalf of the entire JPL family, welcomes you all to this very eventful day when we have assembled here to discuss on a very relevant subject of analytics, digitalization in power plants. It's a very apt subject as far as the present time is concerned. You know, the world is going digital. So all things related with world has to go digital. I will be falling in my duty if I do not express my sincerest thanks to the team Jindal Institute of Power Technology, headed by Mr. Munish Johri, for giving me an opportunity to come to this forum and share some of my thoughts in front of you. Friends, Mr. Avinash and Mr. C.N. Singh has already explained in detail about analytics and digitalization. All through my life, I worked in a mining industry. दूर दूर तक इन सब चीजों से कोई संबंध नहीं रहा. So I will restrict myself on power industry in general and power plant in particular. You all are aware that country is sitting at the crossroad of energy transition. We are at a very unique time, my friends. You know, what development has been seen in the last 200 years has been seen in the recent 20 years itself. 200 years versus 20 years. And now it is going to be even less. In coming 10 years, you will see unparalleled development in the field of artificial intelligence and machine learning. And no one, whether it is industry or whether it is an organization, can remain untouched from those developments. So if we want to keep ourselves in the developed country league, then we don't have any alternative. We don't have any wherewithal. But to adopt and continue to advance in these technologies. You all know, my friends, that India is coming into the forefront of a developed country, but still it is not in developed country. And a country cannot come into the league of developed country until and unless it has got energy securitization. Until and unless you are secure in the field of providing efficient and cheap energy to the entire country, you cannot come into the forefront of developed country. It is really a matter of concern to note that in India, still per capita energy consumption is one of the lowest. You know, our energy consumption per capita is less than 4 units per day, whereas it is 5 times more in China, 11 to 12 times more in US. So if we want to become a developed country, this per capita consumption is going to be at least double in coming 5 years. And it poses a great challenge to all of us who are associated with the power industry. It is our bounden duty to see how the country can be provided with cheapest and efficient power, taking due care of the environment. You are all aware that our country do not have much resources as far as oil and natural gas is concerned. You may be aware that our most valued and imported commodity is oil and gas only. We are importing worth at 8 lakhs crores of oil and gas annually. It is the highest imported commodity in the country, followed by gold, around 2,50,000 crores we are importing every year. And most shocking is followed by coal. We are importing coal worth rupees 1,50,000 crore annually, in spite of the fact that India is the second largest producer of coal and fourth largest resource base of coal. So we don't have any other alternative but to continue to use coal to take care of the energy requirement of this country, because this country doesn't have any oil and gas. And with the best intention, renewable energy cannot take care of the entire load of the country. So thermal electricity is going to stay and is going to stay for a long time. It is our responsibility to see how this thermal energy can be provided without harming to the environment. You all know coal per se is not polluting, but the moment coal burns, it starts giving pollution. So it is our responsibility to see how this pollution can be minimized to the bare minimum level. And in this context, I think analytics and digitalization is going to help us a lot. So this is a very apt time that we have taken this topic for discussion. I am very sure the proceedings of the day will bring forward something, some tangible solution, some tangible issues where this artificial intelligence, digitalization can be put to the best use for providing clean thermal energy to the nation. Please don't make any mistake. If someone says that coal is going to be out, coal is not going to be out. Its in percentile terms, its contribution may be less. You know, nowadays, today, coal is contributing around 72% of the total electricity requirement of the country. 72%, irrespective of the fact that its commission capacity is only 52%. With 54% commission capacity, it is giving 72%. And as far as the Ministry of Power document, it will be providing 52% by 2030, but total requirement, which is around 220 gigawatt now, will be more than 300 gigawatt by 2030. So in percentile term, its contribution will reduce, but in absolute term, its contribution will increase. So it puts us in a great opportunity to see how we can harness these resources to the ultimate benefit of the country and to reduce import to the basic minimum level. And in this context, power industry in general and thermal power plant in particular can do a human service by providing clean, sustainable, environmental friendly thermal energy. And to achieve that objective, analytics and digitalization will go a long way. Whenever I hear that coal is polluting, I agree, coal is polluting. But what is the alternative? If I do not have cake to eat, I cannot allow my child to die hungry. I will offer him bread. If possible, that bread should be filled up with butter. So I am requesting all of you to see how best that bread can be used, how best that coal can be utilized, so that requirement of the country can be taken care of in environmental friendly manner. I am very happy to note that Jindal Power Limited, under the aegis of Jindal Institute of Power Technology, is organizing such type of relevant topics where like-minded people should come on the same platform to discuss and to come to a conclusion. As Mr. Avinash was telling, you must put yourself to challenge. Nothing is impossible in this world. If you put yourself to challenge, then only you can achieve anything. Don't take anything for granted, whether it is coming from expert or non-expert. Analyze it, critically analyze it, and then come to a conclusion. There is no problem in this world which doesn't have a solution. It only requires an analytical brain. You must challenge yourself to the ultimate, and you will definitely get a solution. I don't have much experience about power sector, but in case of coal, I can tell you from my experience, sky is the limit. Anything is possible. The industry which produces X million ton of coal in the month of April produces 3X million ton of coal in the month of March with the same machine, with the same manpower, but with increased motivation. I think it is equally applicable in case of power industry, where still there is a lot of scope for improvement as far as clean energy is concerned. Our only concern today is how to provide environmental friendly, sustainable power. In coming 2 to 3 years, I don't think country will face any shortage of coal. Coal will be abundantly available as far as power generation is concerned. So our requirement is to provide clean energy by using that coal. Our coal is inherently dirty. Our coal contains inherently more dust particles. So it is us to see how best it can be used. And it has to be used because we don't have any alternative. We don't have any oil and gas. We don't have any nuclear power. We don't have any raw material to run the nuclear power plant. But God is very kind, and we have got abundance of coal. India is the 4th largest resource base of coal, enough to last for more than 100 years. So responsibility lies with us. So I would only request you to please keep yourself updated, to please give some time to see how best and how far the industry is progressing. What are the new technology and innovations are coming? How best you can utilize those things under your circumstances and situation? How best power plant can perform given the constraints of environmental sector? But then, as I told you earlier, every problem has a solution. And I feel that a time will come where a technology will emerge where coal can be used in an environmentally friendly manners. You know, Government of India has given a lot of emphasis on coal gasification to see that coal can be used environmentally friendly. From coal gasification, you can generate power, you can manufacture a lot of chemicals, and you can use it in a much environmental friendly manner in generation of power also. At the end, I wish you all the best. I wish all the participants to take away something positive from this workshop and to think positively how best we can serve the country by providing cheap and efficient thermal power and thermal energy to each and every citizen of India. You know that the population of the country is more than 142 crores. It is really a matter of concern that even today, more than 30% of our fellow citizens do not have access to clean water. More than 40% of the citizens do not have access to good health care facilities. We are very lucky. God is very kind to us. God has given an opportunity to serve this country. So I will request all of you to please see this as an opportunity, how best you can serve the country, how best you can take care of each and every citizen of country who you or she is not as fortunate as we are. So it is our duty to see that they are extended all sort of help. And we can do that as far as our case is concerned by providing them cheap, clean and efficient power. At least that much we can definitely do to contribute in the overall development of the country. This decade is going to be the India's decade. India is going to prove in all facets of development, be it technological, be it spiritual. Everywhere, this decade is going to be India's decade. And we are very fortunate that we will be contributing in this decade. So I request you all to please put your best foot forward to see how this industry can gain its further height and achieve its ultimate success. Once again, I express my sincerest thanks to the team Jindal Institute of Training for giving me this opportunity to come to you and to share some of my thoughts. At the end, I will only tell you one thing, that nothing is impossible if you try with full dedication and devotion. Please do that, and please see an opportunity when God gives you an opportunity to serve a needy person. That way, we will be definitely developing ourselves as well as country as a whole. Thank you. Thank you very much.
Thank you very much, sir, for sharing your thoughts. I'm sure everyone has learned a lot just as I have. I would like to thank all the members of the dais, and I would like to invite Mr. Raigarh to thank all the members of the dais, including our honorable chairman, sir.
Thank you, Chiranjeev, and good morning to all. Respected Jha sir, Honorable CN Singh sir, dignitaries on the dais and off the dais, my friends. Really, this is the very auspicious day for us. As Ujjwal said, that initially we have formed a group of C&I community, where most of the power plants of India, C&I leaders are there. And we share our views. And we felt need that there must be one get together where we can meet physically and discuss on the important issues of industry and for ourselves. And that dream come up today. This workshop is organized in the hybrid mode. So many participants could not join physically, but they are in present online. Today, there are about 12 presentation will be there. It ranges from the power plants, solution experts, and academicians. The presentations are from JPL, NTPC, NTPC Lara, Adani Raigarh, Adani Kawai, JSW Jharsuguda, AP Genco Singareni. Then service providers are Siemens and GE, as well as the Exact Space, who are the market leaders in the digitalization and analytics. Not only from the field, but academicians are also there. There is presentation from the IIT Bhilai. We had to be present physically here, but due to their exigencies, they will join online. And so many participants will not present, but they will be participant in the discussion. And really, I am thankful to all of them. I am thankful to our Honorable Chairman Jha sir, who accepted our invitation and blessed us. Our source of inspiration, CN Singh sir, who always inspire us and behind us about the innovations and digitalization. Basically, this concept was given by him. When he joined here, he always pushed me about the innovations and the digitalization and analytics. And in his directions, JPL is moving on. JPL have done so many projects in the digital analytics, and we are working on it. Really, I am thankful to him. Our head O&M, our HODs, who strive for the innovations in the plant, as well as friends. Really, I am thankful to you for coming here, and I hope that you all will be with us throughout the day. Really, it is a very good opportunity for us to share our knowledge, our experiences, and to gain and synergize ourselves. With this note, again, thanks to all of you. And end of this, and also, sir, there is high tea arranged. I request all of you to be there. And after that, sessions will be started. First, there will be sessions from the power industry, and then expert services, service groups, and then academicians. Thank you. Thank you to all. Thanks.
He's selling.
Recording stopped.
देखो कहाँ पे करेक्शन करने के बिल में तो सर हम करेक्शन कर रहे हैं सर डेली बेसिस पे बिल डाउन का जीसीबी में है यदि रॉन्ग आ रहा है वो रॉन्ग दे रहा है तो सेम डे सैंपल तो तुम्हारा भी होगा ना सेम डे सैंपल कौन करता है हम लोग करते हैं या कोई और करता है एक्चुअली क्या है सर ये जो सैंपलिंग करते हैं ना उसमें ये 3 सैंपल बनाते हैं खुद करते हैं एक वो करता है और एक रेफरी रख लेते हैं बट सर ये एक बार तो सैंपलिंग खुद भी करते हैं हमारा हम लोग 25% लॉस एनालिसिस हमारा भी सर रहता है वो भी हम लोग राकेश को रिपोर्ट भेजते हैं और ये सर अपना एक सैंपल जो लेते हैं उसको बोल रहे हो कि 3 पार्ट में डिवाइड करके तीनों का सैंपलिंग करते हैं कम से कम 2 का करते हैं तो एक वो करता है आईटीआई एक हम करते हैं उन दोनों में कितना गैप आ रहा है हमारा और उसका भी कोई गैप है नहीं सर वो मैच हो रहा है हमारा ज्यादा डिफरेंस नहीं है
to be disciplined about the time. Yeah. Earlier we have planned session that the presentation will be there, then discussion session of 5 minutes will be there at the end of the every presentation. And I request all the presenters to provide with that. First presentation is from Tamnar Power Limited, Tamnar. It is about the work done by the JPL team in the analytics and digitalization in the plant and their future plans. Hope that this session will be helpful to other fraternities also. With this note, I hand over the session to Mr. Bhagesh Mishra, who is the AGM in the C&I JPL. He will deliver the presentation, and for queries or some clarification, the team members will come here. And it is requested to ask the questions to get clear the queries. And if it is not possible in this session, then they may ask or clear offline also. Thank you. Thank you very much. Thank you.
Good morning to all. This is a very interesting day and a great pleasure to be here to discuss the topic of digitalization. First of all, I would like to thank our management who has arranged such a wonderful arrangement that a number of technocrats would be using this podium to share their experience on such a wonderful topic. And as a result, we will be benefited with the best practices and what the services are being nearby around us, and we will be utilizing the best. So this is an interesting day, and I would appreciate your attention for around 20 to 25 minutes. I would like to introduce my team. We are a team of C&I executives, and in my team, myself, Bhagesh Mishra, and I have Mr. Komesh Singh, and Miss Pallavi Sinha, Miss Ayushi, and Miss Niti Khatri with me. During the session of 20 to 25 minutes, we'll be discussing about the digitalization, in-house analytical tools developed by us in JPL, use of predictive maintenance tool, which is at the development stage, and the artificial intelligence, which we are in engineering stage and will be using in future works. So can we have just next slide? कोई एक आदमी बैठ जाएगा उधर. Okay. Okay, sorry for that. Yeah, this is the index, what we'll be covering. I just discussed that we'll be covering the glimpse of digitalization, that what it is, why it is being used, and what we are doing now. And then what in our in-house developed analytical tools for the performance enhancement and better improvement of the system. And then use of performance optical tool, which is at a development stage for the best operation practices. And then future use of artificial intelligence, which is in at engineering stage right now. Now, the glimpse of digitalization. Nowadays we are aware that power plants are well equipped with an enormous amount of instrumentation, and that generates a large amount of process data. And basis of that, it requires a huge continuous monitoring and support by the operation team. So they require a continuous monitoring of that process and operation. Here comes the digitalization into picture. Digitalization takes all the scattered data which are entire in our plant. They collect that all the data and create a model. From they record a history, trends of around 6 months to 1 year, and they build a model based on the machine history, that how it is sustaining at 30% load, 40% load, 50% load, because whatever we have, as per our OEM, we have the alarms and trip values for all the parameters at full load only. That we are not being told that what should be the alarm value at 40% of load, what should be the alarm value of 60% of load. So these all things are being generated by digitalization, that depending on the behavior of the machine and analyzing the various other power plant of same type and analyzing the data at the same dashboard. So they generate alarms, trips, various alarms and trip at various points. Now coming to the in-house developments, which we have done at our plant. So that first, coming to the deviation settlement mechanism. It is an in-house developed software which is well equipped with all the latest amendments and great guidelines. It has become an important tool, a guiding software for the operation, and is being used widely to know the load schedule, deviation rate, and real-time profit loss in each and every block. And then coming to the next one. This is a flame scanner frequency availability in CCR. Earlier days, the boilers supplied by the BHL, those were not equipped with the frequency. So, which is nowadays, it is being supplied by them. So in later words, it was developed by BHL, and accordingly, by using the Modbus setup card, which were established the communication directly to the CPU, as our current version of the DPU 4.6.2 is capable of communicating directly to the Modbus. So we collected the data by using this feature and brought frequency into our DCS system for better analysis and flame monitoring system. Now, just for the next one, that is Rabo water pump house. It is an intake water pump house for our plant, which is situated at 23 kilometers away. It was being operated through the local control panel, and so we made necessary arrangements by placing max DNA cards, controllers, and the station for its operation and data logging features like trends, SOE, alarm, etc. We also observed that there was an existing optical fiber cable which was laid from switchyard to the Rabo dam. So we used that spare core from that, and we situated a station in control room itself. So by communicating this, we were able to develop two stations. One was situated at Rabo pump house itself, with having the features of SOE, alarm, trends, history, data logging, and operation. And the same feature was developed in the control room itself through that optical fiber communication. So we are able to operate that pump through our central control room, which is 23 kilometers away, with having all the features which was earlier not possible for us. Then coming to the main plant air compressor. Main plant compressor is being controlled by the controller installed in the compressor itself, which is monitored locally. And its process parameters were not available in the control room. So many times it became a problem to analyze its maintenance activities. Whenever it trips or some happening occurs, then we were not able to analyze that whether it was a furious or it was an actual problem in there. So we, through Modbus communication, we communicated the controller as well as the temperature scanners to in our control room, and made available all the data in control room itself, so that the operation is able to get all the data, alarm, and we prepared a dedicated graphics for that also, so that the operation parameters, winding temperatures, bearing temperatures, and their alarms are available in the control room with history, trends, data, and log, so that it can be better analyzed and it can be judged whether it was a furious or it is having a problem. That can be judged quite easily, and that will be a very advantageous tool to plan maintenance at an earlier stage. That there is some problem in that system, so we should act on that at an earlier stage if any parameter is increasing, which was not earlier possible, as all the data were there at the local itself. Then we have created online heat rate monitoring along with the monetary gain and loss availability for the operation. Along with the help of efficiency department, we developed the software as well as HMI for online heat rate calculation, which includes boiler efficiency, critical parameters like main steam temperature, reheat temperature, feed water temperature, at eco inlet temperature, etc. In this model, we use the design value and calculated the predicted values at particular load, as design values only work for full load of operation. And can relate so that we can relate our performance efficiency wise at any stage, at any load. Earlier, this was possible at only full load. We also converted the gain and loss into the commercial terms by using the formulas so that the real-time gain and loss can be observed by the operation for the corrective actions. Now, we have, as earlier discussed, that we have developed the software and graphics for the monetary gain loss. So as per that current parameters, we created totalizers for every shift so that we can monitor the gap analysis, any shortcoming while operation, and do corrective action or reward the best performing team, that in which shift we are getting the best performance. And if our performance is decaying in any shift, then we can analyze all the parameters, what was the problem, what are the shortcomings, then we can analyze it in a shorter way. Then we have in-house developed a program for monitoring our auxiliary power consumption. We have developed the software for calculating the auxiliary power consumption calculation, which calculation has to be done at every startup. So how much our auxiliary startup power was there at a startup condition. So there are totalizers, we can reset that and start before every start, and it will calculate the auxiliary power consumption up to our desired time, that till yet we haven't stopped it. So as you can see that all the auxiliaries drives are power has been already calculated over there, and there is a total amount up to what it has not been stopped. It will be keep on adding that values. Then energy management system. In-house, we developed a software for energy management of entire plant at one dashboard. As our entire HTLT board, including AHP, CHP, were well equipped with Modbus interface, so we established the Modbus communication and brought the entire database at one dashboard through SQL, Visual Basic, and GE platform. We showcase various dashboards giving real-time energy data of the breakers, and accordingly, we generate report weekly, monthly, and yearly, which has been just shown over here. It can be addressed, it can be checked anytime from online, from the ToomViewer, that we can get the data and reports of our energy meters, that is weekly, monthly, or that yearly. As whatever time we can change it also as per the management decision. Then the chlorine leak detector alarm were made available in CCR as well as fire station. The chlorine leak detector, the hazardous chlorine leak detection at various 4 locations, which is equipped in the micro PLC. We established a communication up to the fire station and provided alarm through hooters and lamp indication in the fire station itself, so that at the initial stage they can come well equipped, that where the leakage is there, and they can come well equipped to handle the situations. And accordingly, we taken those alarms in our DCS system and created it for events, and created an alarm in the control room itself, so that an alarm will be indicated in the control room also, that in this zone or in a particular zone there is a leakage, so that action can be taken from the control room itself, and superior level can be well informed along with the fire stations. This is a JPL water balance. We have created a dedicated graphics by using G Simplicity platform for a complete water balance in a one single dashboard, and allotted the various flow meters of various locations by establishing a communication through different systems and making it available at a one dashboard. As we have the flow data in Rabodam, DM plant PLC, DM plant 600, AHP, raw water, And these are the different PLCs, what we have to communicate to the communication tool to bring that data at a single dashboard. So that, and this only we use for giving data export through OPC to the other counterparts, whichever our flow parts it is required. Then here we in a AHP system, we developed a software arrangement were done, and well informative graphics was developed for AHP all field database. Earlier it was not so informative as it is shown in the top one. Earlier it was not so informative, and it was not having data logging facility. So it was a very a kind of problem that we were not able to see the historical trends and data. So by using G Simplicity platform, we collected all those data and made a graphics, a kind of simpler graphics for the operation view, which were having all the analog data and alarms, and prepared the report by using SQL Server. Prepared a report, and we can include all the reports and data for all individual field base over there. Then use of performance optimization predictive tool at JPL, which we are at the development stage. In this module, we are using exact space. It is in the development stage, and it has a basic three modules: that monitoring, performance optimization, and predictive maintenance. It monitors all the scattered data which is being collected by them, and generates a processed output and give informative information to our operator, so that they can take they can utilize it in performance optimization as well as maintenance activities. This is the kind of dashboard which is being used by ExactSpace. They use Pulse Navigator module. It collects all the scattered data through its navigation module, which is Pulse, and process them and generate them meaningful data to support operation. At initial stage, it records the history data of the plant for around 6 months to 1 year, so that it can create a model for suggesting the band for the optimum values at various different loads. Because currently we have alarm and trips at only full load and that. So this creates a model that I will be showing in the next slide, that how that model and band is being created. It basically uses the design value and generates the predicted value based on the various process parameters, and after comparing with the various points. Here you can see that this is the initial information which is being shared by ExactSpace, that here it is showing mill mechanical health is not okay. Here they have taken the plot of load and the temperature, and they have created a band depending on the history of the plant, that at different load how the plant has behaved and how it should behave. That also has also been correlated with other 600 plants, that how it should behave. So they have created a band that at every load this band should be followed. So for whenever our load is high, the band is upward side. When our load is down, the band is downward side. And this is red one. This is the trend of the temperature. Whenever it is crossing the limit, it is giving at an earlier stage, which was not available to us, that there is some problem, the corrective action has to be taken. And in the incident that workflow, it has been mentioned that expert comment, that suppose after seeing this, what our operation gives the comment, what action he has taken, because it's a kind of machine learning tool. So it also adopts, learns, and it is beneficiary up to what extent we are using it. More and more we use it, it will be more beneficiary for us, because more information will be giving it, its history will be more. It has a different versatile type of problems will be available to it, and it can sense and can give that on such cases this problem was happened. So maybe this may be a reason, this may be a reason. It can give us a number of things. Expert RCA and corrective action will be are there. So it is in the development stage. So our team is working on that only. It's just a kind of a brief just to showcase that this is in initial stage what we are working with, and this will be used by the operation. And this is another one, that is HP turbine exhaust temperature. In the similar way as we discussed for this, Here also CRS temperature, it is clearly showing that observed value is within the range of 341 to 349. But the expected band, it is 358 to 396. So the basis of this band, that it should be behaving in this zone. So they have given a action that HP turbine exhaust temperature steam is low. So the corrective action has to be taken. As it is in the initial stage, so a lot of they are already working on that. So when it will be developed fully, then it will come with a lot of messenger checkpoints that this should be checked, this should be checked. So those all things will become, and it will be a very advanced and very a kind of research for the operation expert services. So that expert service will be given by this tool itself. This is another one, that information provided by CP discharge fast parameter. In the similar way, it is also adopting the same. The band has been shown, and it is entirely above the band range only. So this parameter need to be checked. Then it is at a glance that temperatures, eco inlet, and all temperatures have been shown in this. Now coming to the artificial intelligence tool, which we'll be using in future. This is at just very initial stage that we have received an offer, and we are in engineering stage and we are working on that. So they have just what they have forecasted us, and they'll be providing us that they are having a navigation module based on the same principle, that they'll be collecting all the data. They have the expert management system along with them. They'll be also creating a band with an analytical tool. So they have three basic modules, which what they are offering to us. That is fuel module, sensor validation module, and anomaly detection. So these three modules will be provided by them to us for our process optimization. And the biggest thing what has been promised by them, that coal cost optimization will be also provided by them by combustion tuning and all those things at an advanced stage. When we will be moving in the second and third steps, it will be suggested by them and it will be given. This is what the module, what they are suggesting. The sensor validation module, they'll be learning what our parameters, what our instrumentation parameters are, and how it should behave, and how it has behaved throughout lifespan cycle of 6 months, 1 year or so. So at suppose 40% load, the parameter should be within this range, or at 60% it should be at this range. So it will be keep on monitoring, and if any abnormal value or some check points it received, then it will give alarm that sensor validation is required. There is a problem in the sensor, it needs to be checked. For example, we Excel shift, we got the data of 2.5. Now that means it's maybe the reading is correct, healthy, it is coming heavy, but if it is one sensor is showing 2.5, then the sensor check need to be done. And if operation by mist he has not seen, all those things, all such kind of all parameters, if any parameter is going beyond the limit or it is showing abnormal value, whether it is healthy, but it will validate the sensor's data and then give a checkpoint that the sensor has to be checked, and that will be a preliminary stage. Then the predictive maintenance. In predictive maintenance, advanced maintenance procedure and the expert services what they are providing there, and that will be provided to us. Determine by using this tool, we will be able to determine the maintenance at a very initial stage, and it will be continuous monitoring the pattern, how the plant is operating, how it should behave, and so at earlier stage it will be detecting and suggesting us for the corrective actions in terms of efficiency, in terms of operation, in terms of combustion tuning, in terms of C&I instrumentation, everywhere. Because it will be recognizing our pattern that is being done by the operator, it will be done by that tool itself. Then the possible cost of optimization, what will be? The maintenance time will decrease because we will be knowing at our initial stage, so less manpower will be required, less TNT will be required, less time it will take, because at an initial stage, if we are doing anything, it takes very less time and less efforts too. Then loss of production hours, that we will be minimizing our loss of production hours as we receive any shutdown or equipment failure, then there are production losses. So by using this tool, we will be minimizing our production losses. Then reduction in the spare, as I already discussed, because knowing anything at earlier stage and doing maintenance practices at an earlier stage, it reduces the spare part and cost of supply itself. Then the another module, what is being suggested by the artificial intelligence module, that is fuel module. They'll be monitoring unburned carbon fly ash, and they'll be providing a real-time data so that operation can have a online view of that real-time analysis, and they can suggest for the combustion tuning and process parameter enhancement. Those all suggestions and all improvement modules will become by having the all record of process parameters data. And they have also suggested that they will be by improvising fuel module only, they'll be reducing our coal cost by 1 to 2%. That has to be checked in at advanced stage. Then fuel module accurately identifies the milk characteristics, that it will be checking all the parameters, performance, fuel efficiency, all those things will be adequately, its characteristics and everything will be checked and monitored by this fuel module. Thank you for the session, and it comes an end to the session. And thanks for the your listening patience. And I invite if any queries or some suggestions or something like from the dashboard or some any of the colleague.
Recording in progress.
Okay. Thank you for the session. And I will. Our team is always open to discuss, sir. Sir.
Directly, or you are taking data from all your border kind of same platform. So how you are integrating?
Sir, through OPC server, we are providing all the data to them, and they are recording it and analyzing it, and then they are providing it, sir. All the data are being provided to them through OPC server, OPC interface. Okay.
Good afternoon,
sir.
I'm Ajay from DPC.
Sir.
You said that you have taken the frequencies of the claims channel into the DCS system.
Yes, sir.
So what use is being done for regarding those frequencies? Are you doing some conversion tuning, or what analysis you are doing on the frequencies?
Sir, earlier this frequency parameter was not available. Currently we are using it for the better monitoring of the flame. That currently it is not being used for the combustion tuning and all, but in future it will be used because all the parameters are being made available in the control room. So definitely it will be a vital tool for the combustion tuning. So currently it is only for the monitoring purpose only. Sir.
I have some suggestions.
Sir.
I was seeing that compressor on the unit.
Sir.
You are given the temperatures, you are given the parameters to this.
Yes, sir.
My suggestion would be to be more interactive on this particular part.
Okay.
You should give, loading and unloading cycles of compressor as threads. Because that is one point where you can save a lot. I personally have seen in compressors that while loading and unloading, we are not seeing two things. That it is loading and unloading cycle times. Okay,
sir.
That is very important. Unnecessary pressure drop and unnecessary power consumption. The most important area in power plant is the instrument air compressor. So please put that in your dashboard, and it will help you a lot of cost saving, because many times we have seen that unnecessary we are loading and unloading within a frequency,
Sure.
even though the pressure is not getting dropped that much. So if you will take it into your dashboard, certainly you will save some there. Second thing which I want to add in this particular dashboard is the efficiency of each and every compressor.
Okay.
Because we have seen it many times that
Sure.
one compressor is running at 85% efficiency and second one is running at 50%,
Okay.
And without seeing that, our operators are running continuously at 50%. So I can save, 30% of horsepower on one compressor, which is already there.
Sure.
Now, what I said, that your outcomes should be very clear. That
Yes.
what is my motive to make this that good? We are not showing temperatures to operator. That is not a thing. It will go certainly up and it will trip. So what insightful information which is required to save cost and
Yes, sir.
improve efficiency. So you have already taken the data. Now
Yes.
we have to make those loading unloading trends, which we already made and we saved a lot because
Sure.
we have cut down decompressions.
Okay.
You work because your plant area is very big. One compressor is running at one location and giving air to last one. Okay. The second thing which you should give in this is your pipe sizes. Because air is getting depleted on pipe cycles.
Sure.
So that also you can give in that word so that they can have an inside information that where we are getting drop and where what we can improve.
Sure.
So these are few suggestions which you can include in there. Second is I have seen that aux power screen. Which
Yes,
you
sir.
are doing at startup and shutdown. But one thing which I found missing is you told that these are the values, right? But my suggestion would be you put industry best as a benchmark in the same.
Okay. Sure, sir. For
because-
the comparison,
what
yeah.
we do sometimes is we
Sure,
say
sir.
that we are the best, but you don't mind TBC somewhere is very.
That's true, sir.
So if we will reach to our target, then we will not further stress to that.
Yeah.
So if you will give either one which is benchmark, in the industry, then you will certainly focus more and more on this to achieve that particular factor
Yeah.
which is there.
Yeah,
So
definitely,
these are
sir.
two suggestions. Correct.
Sir.
And give me more insight about this. Unburned carbon in ash because real time monitoring of unburned cache is right now not there. So what technology they are using?
So,
I'll be happy to.
Yes. Yes, sir.
Thank you.
Okay. Thank you, sir. Thanks for your valuable suggestions. And that will be all added. And because of this only, the session will be more fruitful because the suggestions coming from the DAS and the other plants, we are getting the best values and best practices from the other plants also. And to know what the things are being adopted in other plants also. Thank you, sir. Thanks for the session.
Thank you, JPL team. And really, this presentation was very good, and suggestions are also acceptable, and they are really valuable. Thank you. Now, it is the time of presentation of NTPC Lara. And I request NTPC Lara team, Ajay Karadkar ji and his team to present. Thank you.
Good afternoon, friends. How's the Josh? नहीं दिख नहीं रहा. How's the Josh? Good, thank you. To answer Avinash sir's query on the last presentation, to tell you, sir, that UCMS unburned carbon monitoring system is available, and it is available online at NTPC Lara, and it is functional. We are using only for monitoring purpose. We are not using any for correction purpose. If any further details are required, we'll be happy to share with you all. Right? Thank you. So good afternoon, friends. And it is indeed a pleasure to meet you all at this workshop and being held in this temple of learning. Okay. I call this a temple of learning because it is right? Kate sir, would you agree with me? Yeah. So as our ED, the head of the plant, Mr. CN Singh, just observed that our focus should be more from same and same from less. Do you agree with me or not? Right? We are all in the business of making power. So our focus should be more from same and same from less. And the topic for today's presentation is also analytics and digitalization in a power plant, which also aims to focus towards the vision echoed by Mr. Singh. More from same and same from less. Okay? Power plant or any other business is looking for profitability. We are not into some kind of social service. Okay, do you agree with me or not? Okay, we are towards profitability. We are towards fulfilling our corporate social responsibilities. We are also responsible towards environment. Okay, we should not forget about environment, right? Because we are producing power from a fossil fuel, coal, which itself is a pollutant. So these three focus areas we'll be concentrating on in our presentation. And it is in this context that I request your full attention towards our presentation on various tools being adopted by NTPC Lara and NTPC as a whole in achieving those objectives. Okay? So let me introduce my team members who will be taking the presentation forward from here. So we are a team of 3 people. We are guided by our HOP, Shri Divakar Kaushik Saab, who has been a chief guest here some time back. He's our HOP, Shri Divakar Kaushik. Shri Akhilesh Singh is the GM O&M. He's heading the O&M functions. And he's the leader, he's the wind beneath our wings. Okay, we are flying is because of our leaders. Okay, myself, Ajay Keralkar, I am the head of the department for C&I maintenance. And I am assisted by Mr. Upendra Mishra, who is DGM C&I. And we have a hybrid team of consisting of Mr. Sainath, who is looking after the energy efficiency management group. Just to brief you about the NTPC as a whole, as a group. Shall I use this? Yeah. Yeah. अभी हो Okay. So we can proudly say that we are thermal power generators. We are not only thermal, we are also in renewable, we are also in wind, we are also in solar, we are also now into biomass. And our installed capacity is 70,000 gigawatt. Okay, sorry, 70 gigawatt. 72,304 megawatts across all the country. And we are generating about 23 to 24% of the total power generated in the country. This is the breakup of our generating capacity. Right now, we are running 2 into 800 megawatt supercritical units at NTPC Lara. And for stage 2, we have a similar configuration of 2 into 800 megawatts, where the environmental clearance and the final hearing has been completed. We are awaiting environmental clearance. Once the environmental clearance is obtained, we will be going ahead with the award of the stage 2 projects. Our boiler system is supplied by Mrs. Dusan, who is a manufacturer and OEM from Korea. Our turbines are Hitachi. We are having coal linkage from the Talaipalli mines, which is our in-house mines. And our water source is from Saradi, that is Mahanadi River. The unit milestones are in front of you. I need not to read them. So let us carry this forward, and let me ask my colleague, Mr. Upendra Mishra, to carry this presentation forward, who will guide you through the presentation.
Thank you, sir. Now we'll start as an NTPC. We started way back in 19. We started our journey 1986 from Singoli station. This is coal-fired station, and right now we are 70 gigawatt plus energy, and which is have mix of our energy band. We started from coal. We are in wind. We are also in solar. We are also recently pellet-fired our boiler also. And we have also started from a single network to a multiple hybrid sort of networks. we have from subcritical to advanced to supercritical up to 800 megawatts. So I mean to say that we have a bundle of a mix of energy across all sectors and with across all mix. So we among ourselves have data of benchmarking ourselves and have to analyze those data. We have a central system. We will go forward how we have accumulated our systems to gain from them. And next slides. Because safety and environment is the utmost priority of any organization. So we value each individual and also believes that each incident can be avoided. So we have a dashboard across NTPC where each incidents are recorded in the dashboard. Every employees are equipped with the app who has mandatory to record deviations and talks and TBTs as according to their defects. So basically, we have a pool of any incidents which wherever happens in the NTPC, it gets populated in the our dashboards. And we, as we know that wherever incidents happens, it always give a learning to others. So it always helpful, and we have also discussing these incidences in our daily meetings, so that it should not be repeated anywhere else. These are dashboards where we have all data where we can compare where incidents happens. And if we have for safety, we have e-permits logs, which you clearly see what we face problems during manual handlings, because the way of digitalization is to how you automate all your processes, whatever the interaction we manually do or feeding data, or we have getting data from manual interaction, we have to populate and give back to the system so that we can learn the same without fail. So it will stop the human error from the system. We are using the PP usage verification through AI modeling, because this is a pilot project at Gadarwara, which undergoing this. So we have also taken other projects in across NTPC, because we are have pool of knowledge bunch where the certain things is being in trial in some other plants, and that trial, once it's completed, we actually in NTPC we actually enhance and implement other projects sequentially. So this automatically system is at rolling season at Gadarwara, where AI trained model of our PP kits visualization and barcodes at switch yards this is all happening where maximum faults happening at electrical sites. This sorry for interruption. Yeah, this is trained AI model, how it has been done through the app. This is e-permit system is being running at NTPC Lara, where our all permits are shown auditable point of view that we are advancing in next sequence when our last sequence is fulfilled. So everything is permit system is automated. There is no little bit chance of man error through the human. And as we know that our next utmost is environment is equally like safety. We have a dashboard also for that, where we are getting round the clock data, and we have configured an alert system through messaging. As soon as the parameters go beyond certain reasons, like that here, we have got alert for pH or TSS, immediately message goes to concern like C&I who is maintaining the system. C&I instantly act so that the error do not prolong for a long time, because as we know that environment has some statutory guidelines to not violate parameters more than 15 minutes, because above 15 minutes they give you an alerts. So as soon as the parameters deviate from its normal range, like in pH, we cannot go beyond 8.5. As soon as parameters go to 8, immediately message goes to the concerned person. He will act as soon as he get the message. here we have shown that last day some alerts came at 7:32 and immediately message came to mobile. So we have just shown it how it's working. Now the process optimization and automation part, how we are using digits and digitals in those sections. As we know that CA has drafted gadget and now it is in implementation and 25th January 2023. According to new gadget, we have to run at 3%. So currently, which is 1%, we have to 3 times in next 1 year. It is given guidelines, and our thermal load is going to be below up to 40%, and it has to be done in phased manner. NTPC all stations has 55% minimum thermal load. In some other plants it might not be. So in first phase they are working to let it come down to 50 and gradually to 40%. So this is going to real challenge where we have to see how our C&I is the we are considered as the most optimized and best tools first of all to, because we are still not use C&I to 100%, we believe. So C&I has bigger role to play into this. This is what we have our deliverables in our Lara. In Lara, we have tested 42% TMCR right now. While we are getting a certain opportunity which can be harnessed. So we try to go as below as without oil guns, so that how much time we can sustain. So we have sustained for 2 hours without oil gun at 42%. And this gives us a boost to let's try more sort of things. Our ramp rates right now effectively is 1.5%. And as Hitachi is our turbine manufacturer, because of some restriction from those side, we are not able to go beyond trial for 3%. But communication is going on. We'll go ahead. We have to at least open 4% turbine to achieve 3% ramp rates. And we also optimize our startup processes like others. We thoroughly analyze startups. Each startups we analyze, and we categorize those startups based on warm up startup and cold startup, warm sort of that. And we have calculating also the specific oil consumption as per those, and where we can optimize the things. As we know that we have to ramp up at higher rates, and when equipment has to ramp up at higher rates, you can say 3%, the most equipments like fans, mills, they are also has to move faster than 3%. So our fans which are giving draft to the boiler, we have to put sensor into fan so that our fan behave as per the requirement. So in Lara, we have our inbuilt system through OEM also, and we have also really calculated after through different trials that before any fan goes to the stall zone, because we have already the 3 stall probes in our fans, which gives you the tripping values. But there are too many sensors also, like pressure air diffuser and pressure at impeller. We can use those pressure and temperature at outlet to early detect the alarms of when fan is going into the stall zone. And we have plotted a XY plot in the control loop itself for operator, so that operator can around the clock visualize where our fan operates. Basically, this XY plot has Y coordinate of fan inputs, which is a suction pressure taken from, means how fan is getting power, and at the X coordinate there is fan flow. As soon as fan flow is reduced with the same power, it gives early trend that fan is going into the stall zone, because once fan is going to the stall zone, first of all its discharge pressure increases. Once its discharge pressure increases, its flow starts reducing. And if that discharge pressure advances to the suction side, then your suction pressure also starts increasing. So based on those 2 pressure, modeling with temperature, we have given an early alerts, and these alerts come very early than the stall alerts start trips basically on which fan trips. And it is recommended not to operate the fans more than 2 minutes in entire life in stall zone. So these systems are like stall probes are really working for fan in our mostly PA fan are high discharge fans, FD fan after that, and then ID fan sequentially. Apart from that, we have also created in-house at DCS itself, because as we know that DCS is built to operate the plant only. And all our analytics are going outside the DCS, because it is general philosophy that we should not load DCS much to analytics jobs. This is general philosophy. That's why our analytics system is not directly loaded in the DCS. We actually hired the analytics part, like we in NTPC we have hired PADO system from STIAG. You are like it is similar to what Mr. Bhaskar you have described earlier. We have also that system PADO which work on neural network, which also takes OPC data from that. That's why you are more interested how you are doing on what platform you are doing. So we also have PADO for plant optimization, but it is beyond DCS. So actually what operator wants real-time instructions. So this ramp up capability we C&I in-house has developed based on the deviation of its control loops, because we already have control loops and we have its deviations as an error to the loop, and we have suitably weighted to the error. Right now, once we say that which is the most critical parameter in the thermal plants, that is your if you keep your temperature constant, nothing will happen to the boiler, because at 400, because we are running at 800 megawatt, our 400 megawatt set point is also 596 for reheater, 580 568 for superheaters. These temperature remain constant from 400 megawatt once you start up the boiler. So basically your main aim is to control the temperature how long as possible. And we are operating at modified sliding pressure, which is plus 10 kg pressure above the your wide opening position. So our pressure is also varying from 400 to megawatt of almost 100 kg pressure. So we have to track also that pressure. As I don't know where you have learned AGC implemented here or not. AGC is here. Not, na? Because we have also included our AGC system. All NTPC plants are automatic generation control. So we are getting 5% plus minus demand directly from NLDC. So means we can keep our megawatt at 700 plus 40 megawatt and minus 40 megawatt. It is directly coming from NLDC. So our system, once we are getting ramps means we have to ramp up the boiler and ramp down the boiler at 1% as per the grid code. If you will fail, if our ROE will be detected by 0.25%. So as we know that any auto loops behave ideally when it is in a very stable position. So operator need not to worry about its auto loop where it is. They can directly give the ramps and our ramp capability curve automatically sets the ramps as per the deviations. Like we see, if AGCs keep coming from the system, our ramping capability automatically get reduced from 2.5 to 2. Operator need not to change the set point for the ramp capability. And this is being demonstrated here, how ramp capability automatically changes the ramp based on our auto loop stability. Now for operation excellence, I will invite my friends. Vishwanath, please go.
Thank you, sir. So this is the third part of our presentation, operation excellence, which is the more important for in day-to-day business of our thermal power plants, because it is where the system runs, and for running the system, we need to micro monitor the many things through dashboards for the system reliability.
Firstly, this is the water dashboard, which is implemented across many power plants. And we have installed more than 40 flow meters across the plant for monitoring and tracking the usages. And we have a very less specific water consumption for the supercritical power plants of 800 megawatt across our NTPC. It is far less than 2.5 liter per kilowatt hour of the CRC MOEF norms. The secondly, it is the control loop performance dashboard. This dashboard is designed and prepared by the corporate OS of our NTPC, corporate NTPC team, where the most critical control loops of power plant are monitored and monitored, where all the parameters of the for the complete day for 8 hours for the required period, it will be captured with the average, minimum, maximum, and range. And we are not only going for the deviation of that parameters, we are going for the standard deviation of that parameters where control loops are performing. And this directly affects our heat rate improvements, where the superheater temperature, reheater temperatures, total pressures, O2, these all loops are critically monitored. And if any deviation are there, it will be immediately looked into that. This is the auxiliary power dashboard where unit-wise powers of the individual systems are being captured and monitored and trend to day-to-day basis to analyze if any increase of power for any necessary action to be taken. This really helping us to saving a huge amount of APC, and also as per the CRC norms, we have got a 6.25%, and with the supercritical power plant, we are running at around 5.9 to 5.95%. So we have got additional 0.3 to 0.35 additional power which we can generate into that grid. And as you know, 800 megawatt is a very costly business of around more than 8 crore per megawatt and around 52 months of gestation period. So installing such a huge plant is also very difficult. We are environmentally friendly using the reduced APC to the pumping of the grid. Next is the ASLD system. This is the acoustic steam leak detection system, where this system uses the acoustic signal to detect any tube leakages in the boiler, particularly T96, where in any normal sense, this signal will be in a green shade. But if there is a rise and any probable leak, this signal strength will goes up and this color changes to red, which directly indicates there's a probable leak, and the operator sitting in the control room can directly take the decision and immediately stop the unit to avoid any secondary damage. And more than it's approximately 30 ASLD transceivers have been installed here, and further there is a proposal to increase this ASLD locations also. Next is the furniture temperature monitoring system. As a part of EMG, we regulate furnace exit temperature from across the boiler. But in Lara, we have got the acoustic pyrometer, where you can see 8 sensors have been installed across at the furnace exit in first pass. For these 8 sensors will be having individually a total have a 24 pass, which will be measuring the boiler furnace exit temperature, which you can locate the zone wise. And the isometric graph is also be prepared automatically, which it shows what is the temperature profile across the boiler. Next is the load cell, which has been installed in the boiler. Since thermal power plants are very prone for the clinkering and slagging issues, and operator can't know what is going inside the boiler because of the high temperature and high radiance effects. So we have got, as a part of OEM, we have got an inbuilt design of a load cell for the boiler, where four load cells have been installed across the four corners, right, left, front, and side, where in every sheet we'll be regularly monitoring the what is the load for the four cells, and based on that, if any clinkering issues are there, we can immediately take action. But however, we are not faced any clinkering issue till date. But based on that, we are improving on the pseudo performances. The last part of our digitalization is other initiatives which have been implemented across NTPC and some other stations as well. As a NTPC, we have got a huge network of around 90 plants, and we have got a huge manpower. So we have got various initiatives like somewhat for all employees communication, Sampak, and most importantly, the NTPC NTPC Pradeep portal has been launched, proactive digital initiative to become paperless, where all the files, all the note sheets, all the processes have been converted into this. Because of Pradeep, it has become a faceless contract procurement, finance, and faceless HR also. It has drastically reduced the lead time for the PR to PO conversions of the procurement process, where the estimate, award process, post-award process of the C&M functions are completely through this portal. And the finance part of the invoice processing, payments to vendors, and everything has been being done through this portal itself. It's a single platform for all the employees, vendors, and even the ministries also. And there are multiple dashboards for the various users, for the departmental HODs and HOP for the monitoring the progresses. And various financial related audits also being carried out through this Pradeep system itself. And various, since it's round the clock availability, from anywhere and any place, any time, we can approve the file. If any file has been launched within hours, the file is being sent and getting approved from the director or CMD level of our NTPC, which initially used to take days and weeks of the time. And it has drastically reduced our lead time and improved our efficiency. The system efficiency has been drastically increased. Next is a Jyoti bot, where it's a bot developed in-house by NTPC CCIT team, where it interacts as a one-stop solution for various information like contact information, audit, employees information, generation information. It is 24/7 and in-house developed. And further, it is a proposal to include the AI into this. And this is another initiative recently launched, and NTPC, it is the first, NTPC Lara is the first place where this it has been launched. This is a digital ORT. In power plant, in particular NTPC, we have got operation review team where monthly all the performance, past month performance is being reviewed, and the next month performance are being set, and along with it, the various issues of plant related critical information are discussed, and roadmap is being laid. So it involves a lot of data capturing and data monitoring and data preparation, along with a lot of paper presentations and Excel sheets. So these all have been eliminated with a single portal, and all the many report submission to higher management and single point access for many entering and data retrieving. This is something, this sample of how the finally the presentation kind of thing which is being developed from that digital ORT platform. This data is directly being fetched from SAP itself, and it is being prepared automatically. So at the end, digitalization and analytics for power plant is very much required, and is the need of the hour. But digital transformation requires a lot of data to be used in an efficient way to focus and for the process improvement, which leads to the digital transformation, which helps in control room operator for monitoring and taking quick decisions, reducing the outages and proper maintenance. And as a power plant manager, as a senior, the senior management requires the very digital and analytical tools. And with the digital twin recently in various talks, so that would be the next major phase for the thermal power plants for the further progress. These are the references for our presentation, and many are from majority is from our in-house data. Thank you.
Yes, sir. Any question? If you can ask.
Yeah, good afternoon.
Good afternoon.
Basically, I am from IT side.
Okay.
I have seen your PPT, maybe slide number 4 and 5, like PI system.
Yeah.
Basically, I have two questions.
Yeah.
Is your integrated with SAP?
Yes. Pi from SAP, no, we cannot write anything on Pi through SAP.
Second question is, for what quantity you would have purchased the tank? 1,000, 2,000,
Per unit, we have 5,000 tags per unit. So this is the standard for all.
you are renewal SRP in every year. Since
I actually I'm not from IT, so I don't know. Regarding Pi, you want.
We will confirm and let you know. Please leave your contact details. We'll leave it.
Sir, as you mentioned, presentations are being prepared with the SAP data, right? So how we are integrating FHR, APC, all this data? All this data is also retrieved from SAP. Have we migrated into SAP?
No. We told that all our data are from our source only. We didn't say that it is from SAP only. So our source means we have taken data to Pi system, and through Pi we have a tool Pi Vision. You might know more than know. Pi Vision has analytical tool also, where we can monitor standard deviations also over the long period of time. So it is like that. Our SAP is Pi is we cannot write anything into Pi from SAP. This is like arrangement. Anything, sir? Yes. Yes.
The only things which worries me that once we start the process of identifying and monitoring convert carbon, the process of 1 to 2 hours actually. Trying and much. Trying my code because of my boiler is already being changed. So what challenge actually I was asking when I am facing this? Taking some corrective measures. Meanwhile, my fuel is already changed. So I'm getting a train with the same unburned carbon for 24 hours. That is what I was meaning. In case of GCV, we have tried for real-time GCV a lot, and it cost us too much, and then everybody, anti-BC, other plants, we decided not to go for that, and just go with the 24-hour mechanism. Only thing we are talking about improving efficiencies, improving optimizations and everything we are talking about. Then we should take some trials because we are power companies and you are being the flag holder. So if anti-BC approved, then I know everywhere it is being approved immediately. You have a large base and a very big company in that. So please go with this online GCP as well as this ash info. I am exploring this actually. After that, CI comes and trying to get a more right. In order to then we are supplying the coal. And if we know that how much ash percentage is there, then I can, definitely save my boiler. So this is the only thing. As all those things are already there. Yeah, thank you. Thank you.
So just to sum up, actually, what you asked is online monitoring of UCMS is being done. But the problem, as you said, by the time you take corrective action, the coal quality is already changed. So what we are doing is we are trying to correlate with the offline sampling also. We have a chemistry department who takes an offline sample. And if it is there is a correlation between the two, then we take some corrective actions by the operator. As of now, we don't take corrective action just solely on the basis of readings obtained from the UCMS. It is always seconded with the offline sampling. So that is a challenge actually to use it online. Thank you.
Actually, one thing I want to add, actually, we also monitoring a stack CO. So because stack CO and unburned carbon is directly related, you will get the flue exit through chimney. Our CO will increase from, because we are maintaining around about below 100. As soon as you increase the air, it will reduce. So right now we are at that stage only, because directly we are not doing in auto loops so much, because once you disturb anything in the balance boiler, it will create some other problem. So definitely, sir, this your carbon actually exact measurement and GCV is I think next you are thinking about. Thank you so much for patient listening.
Just to give you information that we are already now in a process of installing an FGD, that is flue gas desulfurization. Anybody heard of FGD on the back? Okay, it is sort of reducing the SOx output of the boiler. So it is under commissioning stage. Anybody wants to visit our plant, he is most welcome. Right? Thanks. You have some question?
Yes.
Yeah.
My question related to load cell and boiler. Can you show the slide? Possible. Right.
Second last one. Or yes.
Yes. You have told that the clinker falls and the load cell descends. If it is directly falling.
No, sir. These load cells have been installed on the hangars here, sir. So we are continuously monitoring what is the load of the across the boiler on the four here. For example, let me say this A, B, C, D is the four load cells which has been installed on the top, sir. Top.
Okay.
Top. These load cells which is hanging. Load cells are installed here. Load cells are installed here. So it is measuring the weight across the boiler on a continuous basis. You can see it has been there, what is the dead load, or what is it water, or what will be the ash load. So we are on a regular basis. There is a already in 2019 we have started our unit COD. So we have got almost 3 years data. What is the trend we are following? So we have got the data. What will be the load cell data? So ABCD data we regularly check and monitor it. We trend it, and based on that, if there is any increase on the load cell weight, so there is a direct implication that there is an increase in clinkering across the boiler.
Have you specific data collected through this regarding clinker?
No, that's what we have never faced a clinkering issue till date.
That's what.
Yeah, because we are not, because we are coal we have received, we have never faced a clinkering issue. But if any, pardon? However, the soot or whatever is being, soot blowing is being enhanced based on this data we are capturing. And after the soot blowing, that it has been reduced.
Okay.
Yes, sir.
आता है सर 50%
Yes.
By variation in the level of the bottom mesh,
yes,
the load cell reading is changing. So if the clinker is accumulated there, then that will definitely reflect on
yes, sir. If clinker is hanging on any coils and a superator radiator, the obviously the weight of the hanger will increase and load, already the load of the, it will be increased. Because previously in a 500 megawatt, we never had any system or any technology to see what is happening inside the boiler, how, where the clinkering happening or not, until we come to the bottom ash and we face major issue. Before facing any major issue itself, we are monitoring it. If anything is passed, we are immediately going for soot blowing or LRSP.
With the soot blowing, are you getting the difference in the?
Yes, sir. Where difference in load cell readings have been observed. Is observed, sir.
But then, with the load cell installed in all the four directions, can you predict in which valve the clinker is more?
Yes, sir. Because you can see, sir, this maximum this design data is also for right side and the left side, front side data is different for individual sides, sir.
No, I'm asking, if the, say, on the left-hand wall side, the clinker is more there, where you need the soot blowing. I mean, I'm asking for a targeted soot blowing.
Yes, sir. It directly indicates left, right, or front or rear part, because it directly indicates because 4 individual readings we are getting. So based on that, we can directly attack on that problem.
Sir, as such, by this system, we yes, sir.
We have to
Sir, we cannot predict actually where the soot will be formed, where it will be formed, but we can get
formed. It cannot be predicted.
Yes, but
where it has formed,
yes,
you need
yes,
to do
yes.
the soot blowing. Then
Yes,
you can
yes.
identify.
Optimize.
You can optimize the soot.
Optimize the DM water consumption. Yeah. Thank you, sir.
Sir, good afternoon, sir. Sir, as you said that your plant is commissioned on 2019 and 20, how are you maintaining that particulate matter and SOx and NOx content approximately should be less than 30, less than 100? Sir, how are you maintaining?
You are maintaining it or not? Just you are Sendai guy or?
No, sir. I'm student, sir.
You are student. Okay, okay. Actually, we are maintaining below 30. Okay, through because our ESP, where we have 6 ESP are all are charged conditions, so we are able to maintain. But it is difficult. I cannot say all thing here, but it is really difficult to maintain because the parameter is too low.
But SOx and NOx content?
SOx NOx, because right now for SOx NOx there is guidelines. We have to maintain NOx below 300, which was earlier given 100, I think 100. But there is no strict guidelines to stop the plant on SOx NOx basis. But SPM the 30 is given for new plant, which is difficult. That I can also say.
See,
No more than that.
ESPs are designed to have that value of SPM.
No, sir.
And we have normally say 500 megawatt unit, you are having 4 parks.
Yeah.
Now 660 megawatt or 800 megawatt is having 6 parks.
Yes, sir.
So number of parallel path is increased. And now that FGD, which is coming after that, that SPM level will come down.
Yes, sir. Yes, sir.
Because then the water, as you have seen in the yesterday's Mr. Discussing's section, the FGD में आपका जो water spray होगा, that will reduce your suspended.
Yes, sir.
Yes, sir. Thank you, sir. Thank you.
I hope you are not from environment, na?
Sir, I have a question.
Yeah.
That load cell, it's in the first pass, right?
Yes, yeah, in the first
Uh,
pass.
Also, does that installing the load cell, does that have any impact on the frequency of shoot blowing?
It is only monitoring purpose.
No, as impact the frequency of shielding.
Does that have any impact? You said that we can monitor how much clinker has been formed, right? So does that have any impact on the frequency of shoot blowing?
Actually, the sir has what said, and based on the load cell data, what we actually do, we are only correlating whether the load cell has shown some sign of improvement, and we are doing the shoot blowing at left side, and whether that load cell is decreasing. That data is nearly correlating, but we cannot say that is 100% correlation directly. We are just only seeing the correlation between soot blowing side and that load cell, whether it decrease or not. But it is not 100% correlation. It is rightly 70-80% it is correlating, sir. Where we are doing soot blowing, we have some sign of decrease in the load.
वही करते रहोगे हैं?
Nobody from here. Okay. Okay, thank you. I think all questions. Somebody from online.
What are the arrangements of the?
Till now, we have not faced it, but right now we should be ready for that, I think. Because I think load cell replacement we have not thought of right now. What will happen?
Load cell actually, load cells are prone to failure over a prolonged period of time. And the best way to change them is when the boiler is cold and when it is not firing, because otherwise you won't get the correct readings. So it has to be done offline when the boiler is off for a long period of time. Did I meet your expectation, ma'am? Online? Thank you.
Thank you, Ajay ji, Upendra ji, and Sai Vishwanath ji for giving a nice presentation about the initiatives in the Lara NTPC. Really, there are so many queries and questions about your initiatives, and due to the time constraints, we cannot extend that much. And I request all the participants, offline and online, they may contact directly to them. Thank you. And now is the time of presentation from ACPP Angul. Yeah, they are the participants, furthest participants, I can say. They came yesterday, and I request them to give the presentation. And due to time constraints, I request all the participants and presenters to abide by the timeline. Thank you.
Thank you, sir. Presentation. Okay. Well, good afternoon, my seniors, my friends and my colleagues. First of all, I give thanks to the JIPT Tamnar for inviting us on such a wonderful workshop where we all have come together from different zones of power plant. Thank you, Khatri sir, for that. As said that talents, we don't born with equal talents, but definitely we have an equal opportunity to learn. So thanks to JIPT Tamnar for giving us this platform. In this line, I will add that on the day when our HOD from power plant, Mr. Rafiq Ahmed sir, has received this invitation, he is constantly following up with his team, and finally it was made successful, and we are here, sir. Thank you, sir. So coming to the presentation, sir, we are from SCPP Angul. It is a captive power plant having 810 megawatt capacity. There are 6 units, 135 megawatt. In our SCPP team, I'm Rajiv Raut, and my colleagues, Mr. Pawan Samantara and Mr. Bipin Singh. Digitalization, what is digitalization actually means? Digitalization, nothing but collection of data, segregation, analysis, coming out from some outputs, and use the outputs in a useful way to get some better efficiency, better performance. Now, as we are in a from steel plants, sir, normally steel plants, we have electric arc furnace. The load normally varies from a range of 0 to 190 megawatt if I include the ladle furnace. So we have to increase and decrease our load continuously at a regular frequency, even 23, 24, 25 times in a day. So out of 6 units, we run normally 5 units. 1 unit is always run in house load mode, and rather rest 4 units are running always variable load. The 190 megawatt gap we normally meet with the 4 numbers of units. So by doing this, our process parameter varies. So we as you know, sir, in boiler we normally change our fuel. There are so many. If we increase and decrease the generation, then my process parameter varies a lot, and we are normally doing manually. But definitely this digitalization can give us a magical result, magical improvement in our performance and efficiency if it can be possible. Advantage definitely, sir, real-time process optimization, efficiency improvement is there definitely by this, by digitalization. Minimization of losses is there, sir. And definitely data always says something, and we have to understand that. And digitalization makes us to possible to understand what the data is saying actually. So by this, it also helps. Sir. Next, sir. This is already I have told already, sir. Now I request my colleagues, Mr. Pavan Samantray, to take this presentation.
Thank you, everyone. Thank you to all the seniors and colleagues and friends. Actually, डिजिटलाइजेशन अगर हम लोग बोले कि एवरीथिंग होता है कि लारा ने तो बहुत अच्छा प्रेजेंटेशन दिया है, लॉट्स ऑफ थिंग्स वेरी डिजिटली एंड कोलैबोरेटरी कलेक्टेड एंड displayed to given to the operator or the DEX engineer to control. The thing is, small data भी अगर हम लोग पकड़े ना, any small data to compare with the, अगर हम लोग कर ले heat balance diagram से भी कर ले, only अगर design data से कर ले, everything can be controlled. And the जैसा सिचुएशन धीरे धीरे आ रहा है, हम लोगों को अगर हम लोग ऑप्टिमाइज वे में नहीं चलेंगे, देन वी हैव इन ए ट्रबल. पुराने प्लांट जैसे होते जाएंगे, एवरीथिंग आ जाता है कि आपको एफिशिएंसी हीट रेट जैसे हम लोग बोलते हैं कि मेन हमारा जो पैरामीटर होता है उसको कंट्रोल करने के लिए दिया जाता है कि आपको इस रेंज में चलना है. CO2 आ गया है, कार्बन कैप्चर स्टील इंडस्ट्री के लिए आ गया है कि आपको ग्रीन स्टील प्रोड्यूस करना है, आपको CO2 एमिशन कम करना है. एवरीथिंग वी हैव टू मॉनिटर इन ए डिजिटल मैटर. सो अगर हम कंपैरिजन स्टेज में आए तो हम लोग को एवरी स्टेप बाय स्टेप कंपैरिजन एंड मॉनिटर करने की जरूरत है. सो स्टार्टिंग फ्रॉम द हीट रेट डेविएशन, जैसे मैक्सिमम प्लांट में अवेलेबल है ऑनलाइन हीट रेट डेविएशन. वी आर आल्सो हैविंग द सेम ऑनलाइन हीट रेट डेविएशन, that is the screen available, that is configured in house, and with that we have the losses according to the cost effect also we have installed in that. Then we have the SCADA system. Okay, SCADA system है हमारे पास. Actually, as Rajiv sir told, we have a variation or load of steel plant. Steel plant जिसमें हमारा maximum load vary करता है of the electric arc furnace that takes 140 megawatt. Okay, 140 megawatt vary करेगा. इसका cycle है 45 to 50 minutes का. 50 मिनट के साइकिल में उसको पॉट चेंज करना है, लोड सेल चेंज करना है, उसके लिए उसने टैप करना है. एंड 140 मेगावाट जब वो ड्रॉप करता है, उसके साथ में LF भी है जो अपना लैडल फर्नेस है, उस वो दो है वो भी वैरी करते हैं. सो इन टोटल इफ यू कंपेयर, वी हैव ए 160 मेगावाट ऑफ लोड वेरिएशन इन एवरी साइकिल, एवरी 1 hour. ओके, सो उसको कंपेयर करने के लिए वी हैव ए SCADA सिस्टम, बिकॉज we have configured so many things in house only by the switchyard team actually, and we have some export schedule also. We are having a schedule to the Barbil, our in-house plant Barbil, Odisha, that is available in Odisha, and also we have some export schedule also. So we have to maintain we have to give power to the in-house plant, steel plant. We have to maintain the schedule, export schedule to the Barbil and IX also. For that, we have the real-time export forecast available for the every 15 minutes block, and you can see in that this is, if this is point. this is the export schedule. You can see that 23 megawatt only we are expecting at this block, and our forecast is 68 megawatt. And we have this is the target and achieve and the balance one. So we are continuously monitoring this. This is our target to achieve the export schedule. If you not, DSM rule has been changed, and huge penalty will come. Okay. Then this is our captive load demand screen. That is the different captive units are there, blast furnace, oxygen plant, all are they are taking. What are the loads they are taking? And coming to this, I may add, because though we are monitoring continuously, that is, a plant is taking a 25 megawatt. Let us take an example. Okay, and suddenly and shutdown comes, that is a 25 megawatt will be thrown. Okay, so what happened? We have schedule, IX schedule we can put before the 1 hour 30 minutes. So in that we are having a benefit of giving the schedule for the IX for the selling of the power. And this is the cycle of, there is the 24-hour cycle. This is the pattern, how the SMS is, this is the SMS cycle, and this is our load cycle. Okay, this type of variation we are facing in every day. Okay. So what are the major challenges due to this? The major challenge comes on the boiler part, and another is inform power part. Because in Odisha, SLDC is not giving any single money if you are giving a free power. So what are the challenge? We have to ask for the management. We need to reduce the inform power. And second part is the boiler management. Because when आप boiler को इतना ramp and ramp down करेंगे in a fast manner, तो बहुत दिक्कत है. हमारा अगर कंपैरिजन करें, हम लोगों ने इन हाउस इसको डिजाइन में डिजाइन का पैरामीटर एंड इंडिविजुअल बॉयलर के डिफरेंट जोन के पैरामीटर को इंक्लूड किया. इसमें हमने कंपैरिजन डाला कि हम लोगों का बॉयलर का हीट लोड कैसे चेंज हो रहा है. बिकॉज आपको अगर मॉनिटर करना है, आपको फेलियर रेट कम करना है, आपको इससे CFBC बॉयलर जनरली, सो इसमें रिफ्रैक्टरी है. ठीक है, रिफ्रैक्टरी है, तो उसके बाद आपको हीट लोड डिफरेंट वैरी करता है. अगर आप इतने फास्ट रैंप अप एंड रैंप डाउन करोगे, इट अफेक्ट्स ए बॉयलर ए लॉट. ओके, सो आपको अगर आपको कंपैरिजन करना है, देन यू हैव टू कंपेयर विद द डिजाइन डाटा. ओके, डिजाइन डाटा कंपेयर करने के लिए हम लोगों ने जब देखा, दिस टाइप ऑफ ग्राफ वी आर जनरली गेटिंग. डार्क अगर ऐसा है, तो अगर कंपेयर करेंगे तो हम लोगों ने देखा कि फर्स्ट पास में ज्यादा हमारा टेम्परेचर वेरिएशन होता है, क्योंकि फ्यूल आपका फर्स्ट पास में हमारा है, तो फ्यूल हम लोग जनरली कोल प्लस गैस यूज कर रहे हैं. तो कंपैरिजन जब किए, फर्स्ट पास में ज्यादा टेम्परेचर वेरिएशन है कंपैरिजन टू सेकंड पास. देन कम्स व्हाई सेकंड पास में भी फेलियर होते हैं, क्यों होते हैं? बिकॉज क्या होता है कि हम लोगों को अगर इतना रैंप अप और रैंप डाउन करेंगे, आपका टेम्परेचर आपने मेंटेन कर लिया, सेकंड पास में आप देखिए टेम्परेचर मेरा ज्यादा वेरिएशन नहीं है रेंज में. कंपेयर करने भी जाएंगे तब भी वेरिएशन आपको 20 to 30 डिग्री का वेरिएशन मिलेगा. देन व्हाई? हीट लोड चेंज हो जाता है, फ्लो कम है, मैंने हीट ज्यादा दे के बैठा हूं कंपैरिजन में डिजाइन करने के चक्कर में. दो वी हैव ओनली द डिजाइन डाटा विथ अस, पार्ट लोड में कैसे आपको वेरी करना है, कितना मेंटेन करना है, इट्स ए चैलेंज. आपको ये जब आप डाटा एनालिसिस करने जाएंगे, तब ये हमको मिल पाएगा कि परफेक्ट हम लोग कितना मेंटेन करना है. तो वी आर ऑन ए स्टार्टिंग फेज ऑफ दिस एनालाइजिंग. Then this is the condenser efficiency calculation part, जिसमें हम लोग इन हाउस बिल्डअप किया है कि CW फ्लो की वजह से और एयर इनग्रेस की वजह से हम लोगों का कितना लॉसेस होते हैं, एंड टोटल इम्पैक्ट उसको दिखाते हैं. देन ऑनलाइन एनर्जी रिपोर्ट डेवलपमेंट, दैट इज द हम लोगों का डिफरेंट यूनिट है, 6-5 यूनिट चल रहे हैं, तो उसके हिसाब से कंपैरिजन हो पाता है कि आपका ऑक्सिलरी डिफरेंट ST बोर्ड में, UT बोर्ड में ट्रांसफार्मर लॉस बढ़ गए, एवरीथिंग कैन बी कैलकुलेटेड. मेनी इंडस्ट्रीज हैव, बिकॉज इसका रिक्वायरमेंट इतना है कि आप सोचिए कि समवन मेरा एक लोड वेरिएशन यूनिट में हूं, एंड मैं बोलूंगा कि मैंने प्रेशर मेंटेन कर लिया सर, ऑक्सिलरी मैंने BFP तो कम चलाया ना, इस प्रेशर कम चलाया, मैंने रेटेड प्रेशर नहीं चलाया, मैंने BFP का करंट कम कर लिया. बट आप कंपैरिजन करने जाओगे प्रेशर एंड इलेक्ट्रिक लोड, आपको कौन सा ज्यादा मिलेगा लॉस? तो अगर छोटे कंपैरिजन वे में हम लोग जाएंगे, तो ऑनलाइन आपको इलेक्ट्रिक मीटर और द इक्विपमेंट का मॉनिटरिंग इज वेरी मच रिक्वायर्ड. देन स्मॉल सूट ब्लोइंग रिक्वायरमेंट. यस, सूट ब्लोइंग रिक्वायरमेंट जनरली हम लोग ऑल मैक्सिमम प्लांट क्या होता है कि हम लोग टाइम बेस से नीड बेस में आ गए. ठीक है, हम लोगों ने भी किया, टाइम की था कि पहले 8 आवर्स में कर देते हैं स्टार्टिंग, देन वी कम्स टू कि 24 आवर्स में एक बार करेंगे. But a single operator, if he is operating in the unit, sometimes what happen कि 12 घंटे में 24 घंटे में तो करना है, तो क्या होता है, रियल फैक्ट बोले कि रियल फैक्ट यही आता है कि 24 घंटे में करना है तो रात को कर रहे हैं तो रात को कर रहे हैं, ठीक है. बट व्हेन द अलार्म कम्स इन द बिफोर 8 आवर्स, क्योंकि लोड वेरिएशन है, कोल वेरिएशन हो गया, चेंजेस आ गए, जिससे आपका ESP आउटलेट टेम्परेचर, इनलेट टेम्परेचर बढ़ चुका है, बट स्टिल द पर्सन इज वेटिंग फॉर द टाइम. इससे क्या होता है कि आपका लॉसेस बढ़ते हैं. दैट्स व्हाई वी हैव गिवन ए सॉफ्ट अलार्म, वी हैव ए सॉफ्ट स्क्रीन ऑफ द मेजर अलार्म्स ऑन द LVS पैनल. सो हम लोगों ने सूट ब्लोइंग का एक रिक्वायरमेंट दिया, जिससे आपको पता पड़ जाएगा कि बिफोर में आपका इट्स ए स्मॉल चेंजेस बट इन इम्पैक्ट्स, कि आपको सूट ब्लोइंग इतने टाइम में स्टार्ट करना है. थैंक यू. Some of the best practices we just want to include. Mr. Bipin will take for us.
Good afternoon, seniors. Good afternoon, my colleagues and friends. I will just explain few projects we had undertaken for the improvement of our plant, the power reliability. Earlier in our plant, there was a problem for islanding load. Like during the rainy seasons, there are many cases of blackout conditions when there is no availability of grid power. And all of a sudden, because of unavailability of grid power line failure, our units didn't survive. Because there is a problem, there was a problem in original scheme of governing system. So in order to make available the reliable power for the cooling system of mills, for the blowers of blast furnace, we have to come up a solution which can provide us a reliable power. For that, we had contacted to our OEM, Shanghai Electric Company, and after discussion, we had implemented the project of islanding system in our 2 units. Unit 1 and Unit 6 is now running capable of islanding feature. This Unit 1 is running successfully without grid connection. This is the breaker which we are using as a connection to grid. So we are running continuously 1 unit out of 6 units. 4 units are running in normal mode, and this 1 unit. So in case of 5 units, 4 units are running normally, and 1 unit is running as a islanding system. It is running continuously without any grid connection. So in case there is any problem in the grid power, all the critical loads which are connected with this Unit 1, bus 1, there will be no disturbance in the power. So we had seen successfully that there are many incidents where there was a disturbance in grid power, and because of that, many of the critical loads got tripped. So this unit, which is running in islanding, long-term islanding mode, house load mode, this saves a very huge power as a part of production, as a part of equipment safety also. It is a very vital for us. And during the testing, from full load 135 megawatt to the home load, we had successfully tested after load throw off, and there is a nominal disturbance, nominal parameters which got changed, but after that all the process parameters got smooth.
Yeah,
This is load management screen, because without load management, we cannot survive any islanding system. So this is basically the load management. We are having total 6 transformers, 33 kV transformers, which are connected with different loads. Based upon the priority, based upon the frequency set points, we can make unit available, we can make power availability. Because suppose we are running in house load mode, there is no connection with the grid. Suppose one of the user started more than 5 megawatt motors or any equipment. So automatically there will be fluctuation in the frequency of our bus. So this system, it helps to monitor the frequency and automatically takes a decision by cutting the load with respect to the frequency set point. So this will means prevents us from catastrophic failure by the tripping of the unit instead of only one load to throw off. So this is very useful system, and it is running successfully. And also we had undertaken the project for all the remaining 4 units. One improvement was we had observed in our Shanghai electric turbines. Bearing number 2, there was a problem of oil seepage in all of the units. This is the point from where all the thrust pad RTD cables for positive and negative sides both are coming from this opposite end. There is a problem was oil seepage. So because of that, there are chances of oil. This is oil fire. So after searching a lot, this solution we have got. This is validation port. Basically, this is using in the chemical industry. And this validation port is successfully running in our 2 units, in which we had installed. And this equipment is tested with nitrogen pressure of 8 kg. There is not a single drop of single bubble of nitrogen gas. So it is successfully running without any oil seepage. This is just a small modification because of next Mr. Prabandh will explain that we are utilizing the waste blast furnace and coke oven gases in our boiler as a support fuel, as an additional fuel. So because of that, there are increase in the flue gas velocity. So major damage we had found in our oxygen analyzer probes. So just a small modification we had done, that we had made a this probe protector, we had installed probe protector to avoid damage of main probe. This is just a small modification which we had implemented. Now I hand over to Mr. Prabandh.
Yes, sir. Yes, sir. Just to describe, we have, as it's a captive unit, so we are having blast furnace gas, coke oven gas, scene gas, and basic oxygen furnace gas. 4 types of gas we have, and that we are using modified in our boiler. This is the pictorial view how the 4 burners that is we have modified with the Jasubhai engineering in our boiler, CFBC boiler. That is the 4 gas burner are there that we are using with combination with the coal. And this is the booster we have. And what is the 4 units are saving? 240 crore per year we are saving by using the gas. And this is the new installation for the checking of the welding technology, welding area through the POUT system. That is a phase array ultrasonic testing in place of RT. Some areas we are doing it because in Fins area that will be not possible. Only in the second pass area we are doing it. And this is a pictorial view of the how the POUT system is working. This is another, that is the economizer area getting leakage many times. That's why we have provided shieldings in many areas. Thank you very much. Any questions?
It's the oil seepage from the bearing RTDs.
Sir.
You mentioned that it is a validation port you have used, right? Can you just explain what type of validation it is? How it is used, how it is useful?
सर दिस इज वैलिडेशन पोर्ट। ये जो सर हमारा प्रीवियस केस में आपको एक्सप्लेन करता हूं, यहाँ पे एक फ्लैंज है सर, इस फ्लैंज के थ्रू हमारा टोटल 12 आरटीडी केबल्स बाहर आता है, सेम अपोजिट साइड में है। इस केस में क्या किया है सर, वैलिडेशन पोर्ट में ये सेम फ्लैंज, ये फ्लैंज है पूरा कंप्लीट A1 सेट है, सिर्फ ये 4 स्क्रू हैं जिनके थ्रू ये वैलिडेशन पोर्ट इसमें फिक्स किया गया है। सारा आरटीडी केबल्स थ्रू दिस पाइप आता है और यहाँ पे मेन है हमारा सर सीलिंग। ये एक कैप है जिस कैप को इस आरटीडी केबल्स के ऊपर टाइट किया जाता है यूजिंग ए सॉफ्ट सील। सो यहाँ पे सर जो सीलिंग है दैट इज मेन इंपॉर्टेंट। सो यहाँ पे सीलिंग होने से आपका कोई भी ऑयल सीपेज हमारा आरटीडी केबल्स के थ्रू नहीं है।
मतलब बेसिकली जो ऑयल सीपेज हो रहा है वो कैपिलरी इफेक्ट के कारण हो रहा
यस सर,
है ना?
यस सर।
तो उसको थोड़ा हाइट दे दिया आपने।
सर हाइट देने से भी, इसका प्रीवियस में हमने देखा कि थोड़ा हाइट देने से भी उतना असर नहीं पड़ता, क्योंकि जो वायर्स के अक्रॉस में आकर के डेड लास्ट एंड पे अप्रोक्सीमेटली 5 मीटर्स जहाँ पे जेबी है वो 5 मीटर्स पे, वहां पे भी ड्रॉप करके बिल्कुल जा करके एक पॉट रखा हुआ था। अभी भी जिन यूनिट में हमारा ओवरऑलिंग नहीं हुआ है वहां पे पॉट रखा हुआ है, वहां पे ऑयल कलेक्ट हो जाता है।
इसका मैन्युफैक्चरर कौन है?
टेक्नो इंस्ट्रूमेंट्स। आई कैन शेयर द कॉन्टैक्ट डिटेल्स।
थैंक यू।
यस सर,
वेरी गुड।
थैंक यू सर।
जस्ट एक क्वेश्चन था, ये ऑयल जो बाहर आता है इट इज थ्रू ग्रेविटी है या प्रेशराइज्ड है?
प्रेशराइज नहीं है, नॉर्मल जस्ट कैपिलरी इफेक्ट के थ्रू बहुत स्मॉल अमाउंट आता है, लेकिन वो आकर के कलेक्ट हो जाता है। इसके लिए पहले हम लोगों ने वहां पे ये वुर्थ का सिलिकॉन सीलेंट वगैरह आता है, सारा एप्लीकेशन करने के बाद भी उसको किया था, बट कहीं पर भी हल्का सा इशू होता है तो वो पूरा आता है ऑयल सीपेज। थैंक यू वेरी मच।
Recording stopped.
थैंक यू टीम ACPP। आप लोगों ने तो हमारे आंखें खोल दी है। रियली हम लोग समझते थे कि जो कैप्टिव पावर प्लांट वाले काफी छोटे होते हैं और बहुत ज्यादा नहीं करते होंगे, लेकिन रियली जैसे हम लोग सब वी आर स्ट्राइविंग फॉर द फ्लेक्सिबिलाइजेशन। सब थर्मल प्लांट वाले फ्लेक्सिबिलाइजेशन के बारे में बहुत ज्यादा बोलते रहते हैं या फिर करते रहते हैं हम लोग, बट जैसा आप लोगों ने किया है कि आइलैंडिंग ऑपरेशन है, देन आपका रैम्प रेट है, या जैसे आपके ऑपरेटिंग कंडीशन है, रियली दे आर वेरी चैलेंजिंग and due to necessity you have developed yourself कि थर्मल पावर प्लांट में अभी भी आइलैंडिंग ऑपरेशन जो है इट इज इन बुक्स। कुछ लोगों ने कभी भी किया हुआ है तो बस वो दिखाने के लिए किया हुआ है, बट यू लाइव दैट कंडीशन and really it is learning for us. With this we will conclude this renewed session. Actually, we are too late. We have to complete one presentation of JIPT-Jharsuguda in this before lunch. Now we will cover that in second half. In second half, there is presentation of Siemens Limited, Adani Power Raigarh, IIT Bhilai, Adani Power Kawai, GE Exact Space, and AP Genco Singareni, as well as left out JSW Jharsuguda. And we will now go for the lunch. And what time we will come? By 2:15. Yeah, we will come back by 2:15, and we will start from the Siemens presentation. Is on flexibilization. And lunch arrangement is in guest house for the guest and the employees, and the students will take their regular lunch in JIPT. Thank you very much. See you again at 2:15. Thank you. काफी लोग हैं तो जुड़े भी है। Okay, good afternoon, and again welcome back to the workshop sessions.
Recording in progress.
Actually, we are lagging with 2 sessions, whatever it may be. Now I request Mr. Ribilo and Mr. Go from Siemens Limited to present their initiatives in the digitalization. The topic is flexibilization issues and digital twin. We know that Siemens is the market leader in the digitalization, and he has given a lot for the global power sector. You know, turbines Siemens contribution in the power sector. They have given turbine auxiliaries, turbine controls, as well as the performance improvement in the power plants. Now, as there is a need of the flexible generation for the thermal power plants, and Siemens is working on it. And definitely this presentation will be helpful to the power fraternity. With these words, I hand over the session to Mr. Rivero and Mr. Gaur. Thank you. Thank you very much.
Thank you, Mr. Katre, and good afternoon to all the members here. I would just like to check, am I audible? Is everybody able to hear me?
Yes, sir.
Okay. Okay, thank you so much. One question, would somebody share the screen, because the screen sharing is disabled for us. If somebody can share the presentation, good, or you could enable sharing, and then we can go ahead. Whatever is comfortable for you.
Yes, sir. For presenter, there will be enable sharing. Request to do it.
Okay.
ये की मशीन में इसी में इसी में करना है, इसी में करना है। नहीं तो पूछा उनको।
Archan, could you try sharing screen? Is it enabled for you?
Just let me check. I think it might be due to the browser version. We are not able to. There might be some.
Okay. Sir, can someone share it at? Okay, let me. Okay, I think, yeah. I think it should be possible now. Is my screen visible to the audience there? Is my screen visible now? Okay, then I will go ahead, and good afternoon to all of you all, and thanks for this opportunity. Thanks, Mr. Katre, for the wonderful words of introduction for Siemens, Siemens Energy, as we are now carved out. So my colleague Archan and I will spend the next half an hour making you aware of the solutions that we have for flexible operation, also the thermal twin that supports us in analyzing the plant and taking corrective action. Now, setting the the tone or the content. For this workshop, I think this topic must have been already spoken a number of times today, but we are primarily in this situation of flexible operation owing to the increase in renewable operation, which is also the need of the day. We have had challenges in achieving the targets of the solar power, but we know that the government is committed, and this is just a snapshot of this is just hello. Okay, I'll do that. Yeah, okay. Okay, sorry, I come back to the presentation. So, okay, I think my screen is visible, and probably I'm also visible. So this is the growth that we see in renewable and non-renewable also. We expect only some additions in the near future. So what does it have for the thermal plants? So we have to be there's a need for us to be agile. We'll have to handle new minimum loads to accommodate the renewable or the renewable power in the day, especially for solar. There would also be a need for improving efficiency. We know that at lower loads, efficiency is a challenge, and also maintain the lower emissions and thereby get permissions to be operational and supply power to the grid. What are the when we look at for all the power plant fraternity, what are the what are the solutions that Siemens provides and how it will benefit you? Benefit is again linked to the challenges that you may be already be facing or you can anticipate. So we know a lot of solutions. Turbine can provide a lot of solutions, but the challenge, especially when you have to be flexible, is in boiler. Boiler, there is a definite time that it takes to increase the boiler parameters. So boiler is always on the pretty slow, and the turbine is fast. So we need to coordinate. And how do we use advanced process control? That is a key. So there are also, it is necessary to have better operation and better control of key parameters like read temperature, mainstream temperature, flue gas, the intelligent soot blowing, all in the context of flexible operation. And what benefits do we get? The benefit that we get is once we provide solutions in this direction in terms of I would elaborate that in the coming slides, but essentially we are able to achieve higher load ramps than now. We would have minimum human intervention because we optimize the process control in such a way that the air fuel ratio and the necessary corrections are done in an automatic way. We also take it, thereby also the plant efficiency is taken care of. And by studying the plant, analyzing the plant, and providing the solutions, we are able to get a new stable operation at a new sustainable minimum load. So for plants of different ratings, they are now operating around 55%, 60%, some at higher loads, some have gone at lower loads. But the need from CEA is 40%, and that is what most plants have to achieve in a particular phased manner. Also, as you go down on the load, when you go below 50%, it helps when you can switch off major auxiliaries and thereby save auxiliary power. This also depends on number of criteria, but automation can then be modified so that you operate probably on a single stream. Again, this supports you in the plant efficiency, improving plant efficiency. Auxiliary power is consumption is optimized, reduced, and again here we can go to a regime where minimum operator intervention is required. For example, mill scheduler. When coal mills are operated manually, it's a bit challenging, but when you operate the coal mills in sequences, it is then possible to implement a higher level sequence above the mill scheduler, which then decides which mill should cut in or cut out depending on the load variation. Sounds challenging, but even at a 500 megawatt NTPC plant, it has been realized, and it is very much liked by the operator that today they would like to go only for the automatic mill scheduler operation. Now, when we have flexible operation, one thing the mechanical fraternity will surely agree is that the thick wall components are impacted. There is a lot of apprehension what will happen. Yes, they will be impacted quite a lot can be taken care through the advanced process control, wherein we decide the gradients, we look at the metal temperatures, do not violate limits. But nevertheless, with the cycles and the switching on and off, there is definitely creep and fatigue. So this can be monitored through the advanced process control called fatigue monitoring system, and this can be made transparently available to the operator and to the plant maintenance management, so that looking at the impact on the thick wall components, a proper we can plan we can plan the outage when there is a corrective action to be taken on this thick wall components, and not that we are blind and fall into a trouble and have a crack initiated and problem with the component. There's a notification by CA where they want the ramp rates and the load has been defined. So they want plants. I've just there's an example of 660 megahertz here, but depending on your plant, you would be aware of the plant rating. So you would have to go to 40% of your rated load, and the ramp rates decided by CA are 3% from 1%, sorry, from 40 to 55% load, 2% load ramp rate from 55 to 70% of maximum load, and 3% ramp rate from 70 to 100%. So this is something which the CA has communicated to the plants. There are 4 phases. Depending on various criteria, CA has identified the plants, so that from now till 2030, you would have all the plants, thermal plants, being able to operate in a flexible regime. So there is a phasing schedule, the number of criteria, as we said. The first phase are the plants that were commissioned from Jan 16 to 22. They would have to be tested and modified by June 24. So you have, this is the pilot phase. Then you have first phase, which has to be done by between July 24 and June 26. When we say what has to be done, the tests have to be done. The plant has to be analyzed, and necessary interventions have to be done, so that the minimum load can be, you can achieve the new sustainable minimum load of 40%, and also the ramp rates, as I just mentioned in the previous slide. So you can see 4 phases from now to 2030. They expect that the plants should be, the number of units are explained. So these number of units should be tested and they should be capable of flexible operation of as specified by CEA. Now, I think we are hearing this from number of years. So there are different sort of apprehensions. Some have apprehensions, some have actually worked with us, some have heard it from other plants. But just to set the record side, there is nothing like one size fits all. Even if you have 3 or 4 units of the same rating, you'll have solutions that are quite similar, but it'll never be the same. So typically, the Siemens approach is we go by understanding the plant. So we have sets of questionnaires that we understand the plant, how long the plant has run, what is the degradation level, what's the automation level, how's the combustion stability, what are the procedures you're following, what are the challenges you're facing, and if you have done any attempts, what are the hurdles. We also take data, we take process data. So one is knowing your plant, second is actually taking data of some of the plant operation, maybe for a ramp up, ramp down, particular challenges. So these and we analyze the data and see how your plant is performing. Based on this data, based on the design data, the plant data, and sort of interactions with the operation and maintenance stuff, we can align on some wind load tests. These wind load tests are then performed. I mean, in the event of an order, we can actually perform the wind load test based on the schedule that you get with the load dispatch center. And this would typically entail reducing the load in a format or in a pattern that was pre. Pardon me, sir. Okay, I think that was not meant for me, so I'll go ahead. So what we do is we can reduce the load until we achieve the value, or we achieve or there's an obstacle. Obstacles could be obstacles that are surmountable, maybe a manual definition or a field error or correction, and based on that we can go ahead. If maybe some loop is not performing well in auto, we can take it in manual, And until we reach a hurdle, really a hurdle, for example, the exit temperature is too low and not good for operation. So based on what hurdle we face, it would determine at what minimum load can we run the plant. Based on the data, based on the test, based on the analysis of the data during the test, we can a report can be prepared, and which the operator obviously would know because they are part of the test. This can be presented to a thermal plant operator, and based on that, you can know what interventions can be implemented at your plant so that you achieve the CEA directives. This is just an example of what questions typically known to those who operate the plant. What is the soot blowing? What are the CO values from the combustion point of view? Then there are some questions on flexibility, which are related to other countries, like is it better to have frequency control, and so on and so forth. So these questions are typical just to give you an idea of what we try to understand from the customer. This is a typical schedule that you would see that this was this was for one of the plants. So this schedule in your case would be determined and established with the operators. Of course, the operators would take a final call, and then the load dispatch permissions would be key for performing the test. What are the key interventions that we have found necessary? They are essential. It is, again, as I said, no one size fits all. It may be different for different plants depending on what they already have. So the min load reduction is the solution number one. This solution is essentially a combination of solutions which would test the controls at different levels of power plant operation, and it would determine what needs to be done. Do you need to do basic controller tuning, or you need additional loops so that the main controls, drum level and so on and so forth, are operating better at lower loads from 60 to 40. It would also mean adding additional sequences. It would mean testing the sequences, putting the existing sequences in auto. For example, if the operator is getting a mill into operation, is he doing it in a manual sequence? Though he may be comfortable, it would be then transferred to an auto sequence. Then the mill scheduler would be slowly introduced and tested so that the mills could be taken in and out of service based on the load. If at all you need additional instrumentation like CO, flame sensor, this would be identified during the test, and accordingly these can be provided. Net result that this solution provides is, you at the end of the basket of solutions under this min load reduction, when it is implemented, you are then able to operate your plant at a new minimum load, typically a target that we have 40. You will be able to operate this with minimum operator interventions. You will have most controls in auto, and you would also be able to achieve the ramp rates. It depends, again, depending on the boiler, the fuel, what ramp rates. It could be most probably those ramp rates are achievable, or you could even achieve higher than that. So at the end of this solution block that is implemented, you can have the following achievements. Another important optimization block, which is also useful in general, but particularly useful here, is the temperature optimizer block, which is based on state space control and first principles. Here, while implementing this block, the net result is you are able to get much better temperature control. It is based on number of factors, wherein you get action over the entire range, and you are able to reduce in a steady state or near steady state with small disturbances. You are able to reduce the control deviation to bare minimum. Also, any disturbances are controlled in just maybe 2 or 3 cycles maximum, and this gives you very stable temperature control. Many a times, operators are maintaining the mainstream temperature set point a little lower than the actual set point, and the reason being, there are high fluctuations, and you could violate material or metal temperatures. Once they see that this is once it is possible to get better controls, then generally the operator is also increasing the set point. This gives you better efficiency, and this is how we can improve efficiency even at lower loads. Soot blower optimizer at most plants, there is some sort of a stabilized behavior pattern when there was a very fixed load operation. Now you know that the load operation is not fixed. There are times when you have to really vary the load depending on the demand, and which it's not the same. So hence the amount of soot deposition is not the same as before. There it therefore becomes important to use a different method, and what we suggest is intelligent soot blowing. You don't need additional instruments or heat plug sensors. We use the existing medium to identify the heat transfer, or let's say the heat or the fouling level, depending on the heat transfer. Based on that, you have individual soot blows that are activated. This takes care of number of factors. It gives you a cleaner boiler. It uses less energy, auxiliary power, and steam. So this is one of the advanced process controls that is a solution as a standalone solution available from Siemens Energy, but makes a lot of sense when you are implementing flexible operation of your thermal plants. This is just an example of what all are. There are a number of factors. In a forum like this, we can just give you the idea, but the actual soot blowing has number of factors, like the cost of soot blowing. All this is taken care in the software, so that you have soot blowing that is intelligent and gives you all the benefits. So just an example here: flue gas and the transfer to the steam or the water, and accordingly we calculate the fouling. Frequency control. This again gives you a short RAM. This is implemented one of the plants where you normally can give frequency support using the turbine wall throttling. This could be typically 4 to 5%. And in addition, you could also throttle condensate. So if you see, when you throttle condensate, as soon as you throttle or minimize the condensate flow from the hot well to the deaerator, through the LP heater, you have less extraction of steam because of the reduced flow of condensate. This reduction of extraction thereby converts into power production, and you get typically 1 or 2% additional power generation. So totally, you can even go to 5 plus 2% frequency support, primary frequency support. So this is easy to explain, but in automation, we need to do a number of tests to see what sort of what is the contribution to the megawatt when you reduce the extraction. What is the, are the valves wide open already, or if not, what is the support you can get from the walls? How much can you regulate the level? As soon as you close, you regulate the flow, the hot well level will keep on increasing. It could go to dangerous levels. So we decide at what level we should stop. Deaerator level will keep dropping. So these both need to be normalized. At the same time, firing needs to increase. So it's a combination of all the different controls that should happen without any manual intervention, and you should be able to get this support of say 3 to 5 to 7% of the total load increase in a very short time. In a 500 megawatt in Delhi, we have managed to increase 7% in 20 seconds. So now we explained why the need for flexible operation, how we go about doing flexible operation, the main solutions that we give, and from what we hear in the market. You hear a number of terms, and like we have a forum today for analytics and digitalization. What exactly goes into the power plant? You have also many senior people sitting here among there, and maybe in the audience who know that it's also a lot of physics. So how do we go about? So typically APC is the go-to solution. So basically on the physics or the first principles. Then we use advanced process controls. Depending on the situation, we also ideas we see what is best suited for a particular solution. If a customer is moving from a fuel, existing coal fuel, to some other fuel, then also artificial intelligence is important to see what is the impact on the effects of combustion, O2, steam temperatures, and also a digital twin can be used so that you know how your plant is performing as against the desired design values. This is something that my colleague Archan would touch in shortly. So again, for combustion, as we said, we've got basic solutions, and with APC, at times, depending on the type of the boiler, for low ash, we go for laser-based solutions, which give you the amount of effects of combustion at just below the gooseneck area. There are also solutions like coal flow measurement system. in many plants, when they reduce the load, they identify that there is a flame failure on account of which plants have been tripped. It has been discussed in many circles that this could be because of the improper flow in all the four directions, on all the four corners. This can be overcome by a coal flow measurement. So the coal, I just go to that. That's not okay. So the coal flow measurement can take care of the measure the coal flow in all the four pipes, and you can also further go ahead and install variable orifices and regulate the coal flow so that you're having near equal coal flow in all the four pipes, thereby having a more balanced combustion. Again, this talks about, I will skip this because in the interest of time and repetition, this talks about a strategy manner which uses what's best for each particular challenge. And how would you see when a customer implements an APC from Siemens, there is something that is discussed, thought of with the plant operators and the plant personnel, and there are clear optimization targets. So these targets are right on top. To achieve these targets, you have particular parameters that need to be controlled, and to control those parameters, you have particular strategies or particular control areas like air staging, fuel staging, burner tilt. So based on that, you will have action on you will have a direction optimization and a final impact on your main KPIs or the optimization targets. So this is the overview of the broad slide, how we control or go into analytics and digitalize the plant. This is one level deeper slide which talks about the initiatives by the APC from Siemens. This is the FMS system that I said at the beginning. So you can have the FMS system, you can have online evaluation. It is possible. You can actually see what is the fatigue that is undergone by the thick wall components, and you can the benefits is you can actually get a transparency to the impact of the operating mode on the residual life. So when FMS is commissioned, you have the existing and the residual life of the component. You can see how much of the residual life you are eating into in different modes of operation, and therefore go for the mode of operation that is most beneficial to your plant. You can decide the optimum time for the overhaul, knowing that the time for the next crack initiation. So, you can actually see the number of cycles to crack initiation. Accordingly, you can plan your shutdown time. So all in all, in simple, to give a simple simple insight into what this software does is transparency on the stress to the thick wall components, and thereby different modes of taking action at the right time and saving outage times. These are examples of plants where we have done tests that the way we described. One of the plants we also achieved most of the solutions and are in a position that the plant can then now go to loads that are 40% with minimum manual intervention. As we were introduced that we have number of contributions. So the DCS that we have is there at many plants, but not at every plant. So you could have a plant which has no Siemens DCS, something like here, what we call third party, or you could have a plant somewhere we have the total Siemens solution. It doesn't matter. There is no hindrance, no challenge in implementing our optimization solution. It can be implemented in such a way that you just need to interface to the existing plant DCS, have a signal transfer, and accordingly we will make changes. This shows you the interface, how we get connected, and what we do is once this green system belongs to us and the gray system is the existing DCS, which is non-Siemens, we see the plant performance and we add small delta set points that then take care of the new set point finally bring you to a direction closer to the desired value. So you are bringing the plant parameter or the KPIs closer to what is desired for you. We take care of not giving big bumps, not giving big ramp rates, and also switching of these biases in the event of a failure. There's a heartbeat measurement or a watchdog which takes care of the communication. So if there's a communication loss, then immediately this would be to zero. So the existing control would be in place. So with this, I now hand it over to Archan. You can let me know when I need to change the slide. Over to you, Archan. Archan, can you hear me? Hello. Are the people in the room able to hear me?
Yes.
Yes, yes.
Okay, I'll just check why my colleague is not able to communicate. And
Hello. Yeah, I think now it's perfect.
mute.
Yeah, now you
Can I share? No. Again, sharing is got disabled. Is it enabled for Archan by any chance? Archan, it's enabled for you, it seems. Can you check?
just a minute.
Yeah,
Okay.
yeah. Yeah, okay.
Yeah. So, thanks, Ian, for giving a brief description about flexibilization. So, now as we had moved from flexibilization is the need of when there is a renewable integration, but uh, as we go for flex operation, there is the degradation which is occurring with time is more significant than we have seen during the past when it was running at the base load. So it's now become more important to track this degradation on time to time basis, as it might lead to some unseen or force outages if the things are not being taken care at a regular interval or period of time. So the better way is to have a track, and in order to have the track, so there are two or three aspects that need to be taken into consideration. The first part is means as the boiler is mainly dependent on coal and coal quality, we will mostly talk about the steam turbine, as it has much more bigger impact on which the controllable parameters are. So whether we know that the percentage of degradation with in respect to the operation behavior is aligned with what currently our steam turbines are operating, and as the part loads are getting more and more injected, means as the renewable is getting more and more injected and part load operations are more significant, so do we have an insight about how the plant is operating in real time, or have we have the component level feedback that how a component is behaving on the basis of its operation? So all this question is basically talks about that there should be some physics bees or a twin which can really just go and create and create a profile. Means in our software, we just create a physics-based model of our complete plant, in which turbine, heat exchangers, as well as condensers and other components are getting exactly replicated, so that there is one point which is design performance. The another point is with respect to the expected performance. That is, your plant should, with this boundary condition, your plant should behave in that manner. And if that your plant is not behaving in accordance to that, then there is a gap between what is there in the expected and what is there with respect to the measured value. And if it is not getting been tracked properly and been rectified at times, then there's of course loss on the in the terms of unseen outages, as well as in terms of performance getting deteriorated on a more basis, and there will be more maintenance at the end of the day. So these are the some of, means with this modeling concept, we just bring that all the components getting replicated on a physics based model, and they are getting tuned time to time in order to track that the plant is being performed in line to what is there actually, and they should be behaving in similar manner that they should. So these are some of the figures and facts that you can get out of thermal twin if you are implemented for one of the sites. So how this basically works? So all the data are being collected through our tool in a similar manner like OPC or through Pi servers, and then they are getting through our physics-based model in which all the plant components are being modeled, and as soon as the output is there from the plant simulations, there we will be getting expected and the measured results. So all these results are being compared in the performance advisory, as well as our group of experts which are there analyze the data, and the feedbacks are being sent to plant, and they take the corrective action. So along with APC, that further how much optimization can be there in the plant can be easily tracked through this solution, as we know that in respect to performance, that how further it can be improved, so that the optimized results are being achieved in the plants, in the current plant scenario with the current boundary conditions that we are having in the plant. So this is basically the models which are currently running in our system. One is the thermodynamic one, and another is machine learning model. So thermodynamic is basically means creating an physics-based out means models on which your plant boundary conditions have been simulated, and on the basis of your plant boundary conditions, all the predicted outputs are been derived, and they are compared with your measured output. So if there's a gap between measured and predicted, then your optimization should work in order to close this bridge between the measured and the predicted one, in order to have the best achieved plant performance in the current boundary condition, as boundary conditions are not in our hand due to certain reasons for coal and other aspect. Ambient is also one of the conditions. And the another model is with respect to machine learning part. So this is with respect to what your actual behavior of the plant should be when it is in new and clean condition. But as the plant has been run and seen deterioration over a period of time, so with this, it has learned that in past I had, with this boundary conditions of pressure, temperature, and condenser back pressure, I had performed in this manner. But today with this boundary condition, I'm not able to perform in this manner. So you can easily track the gap that is there within the system, so that you can have an early insight that how the performance of the plant should be. With that means as the deterioration can easily be tracked from this point also. Within this, we will be catering all the major parameters or the KPIs which are there for a plant performance. But apart from that, if any sort of customized KPIs are also there, they are also being easily be tracked within this system. And these are comparative dashboards which are there, in which you can easily track what is the power loss or the efficiency loss due to a certain components, like the main components or KPIs with respect to efficiencies. Or if you talk about boiler, then if the flue gas DP across air preheaters are increasing, then what is the loss in terms of power and output. So all this part are being taken care in through a dashboard. These are the various reporting formats. So you can have an HS or TS diagrams along with XY plots and inbuilt generating reports, as well as the dashboards that can show you that what is the current state of the plant. These are some of the different configurations that can be further taken care or customized as per plant to plant level, or what further can be taken from this part in terms of reporting. So these are a few of the use cases. The first use case is with respect to the erosion and corrosion prediction. So within this tool, as we know, minute physics behavior through blades to blade, then at that time we can easily predict that if you further lower your condenser vacuum by 5 or 6 millibar, then what will be the moisture level at your last stage blade. So whether that last stage blade can tackle that moisture level easily, because in because in Siemens design there are some slots which are there for moisture removals, as well as the L-1 and L-0 are flame hardened for a certain level in order to have strength of these blades. So we further advise customer to, by looking into this aspect of erosion corrosion indexes, and then as you will lower the vacuum further, then there will be improvement to that they are been currently seen in the plant where we are doing this monitoring on the day-to-day basis. Another is with respect to early detection of the deposits. So it is directly reflected to output of particular cylinder. So as we are tracking the cylinder power output as well as efficiency on minute to minute basis, you can easily detect that as soon as the power output there's an directly increase in the main steam pressure at the first stages and decrease in the power output, the deposits are being tracked in the steam path, and that can be easily tracked through a real-time tool through this part. So these are, I think, two cases which I want to discuss. And yeah, this is what from our end with respect to flexibilization and thermal twin part. So yes, Jan.
Yeah. So that's all from both of us. We thank you for your attention and wish you a better remaining part of the day. If there are any questions, do let us know. We can answer.
Sir, I have one question here. Siemens has distinct Lalitpur.
ये मेरे फ्रेंड
What stage it is?
ये और मैं एक साथ काम किए थे
I am audible.
एक साल हो गया 1.5 साल हो गया हम लोग बोले साथ थे।
Yes, you are audible, but there is some additional person talking in between. But yes, Mike, Arjun, would you like to take that question?
It was not audible to me. Can you please repeat?
My question was that in Lalitpur plant in Uttar Pradesh somewhere,
Yes.
technology and this neural network that's what have given awarded to Siemens. So we have learned from in some paper that it was in 2019 it was awarded. At what stage it is?
With respect to thermal twin, yes, it was completed in the month of I think 21 or 20. It's 22 March or after COVID. It has been completed, and with respect to laser base, I think Ian can further tell on this part. Zolo.
No, he was asking for thermal twin. Laser, we have done some tests, but that is more in the private domain. It is not in public domain.
Okay. Okay.
Yeah. And just for your information for the team, the Archon Gore is on the panel with Germany, where he works on these thermal twin projects for India and for the Asia Pacific market. Any other questions that you would like to ask?
My question to you is saying that residual life of your model and tell me how. So these are the manual inputs which are associated with how you are taking that life and without the features of what
Arjun, this question is on the FMS. How do we calculate the residual life of the components? Would you like to support me on that?
Sure. Means for starting means as a starting phase of FMS, first of all, we collect all the means latest RLA reports that are there available with the plants, and apart from that, how the sensors are being located within the means within the stream and the fluid system. So once all this data are been there, the remaining means on the base of FE analysis, we will first calculate that what is the remaining life of the component, and on the base of that remaining life, further means further tuning within the models are being done, and how many components that we need to, because for a steam plant there are means for a combined cycle there are around 20 to 25 models that we prepare, but for a steam power plant there are more than 50 or 60 70 odd models that we need to prepare in terms of headers, in terms of Y pieces, which are all the thick wall component. So all this means as per availability of pressure and temperatures, we decide that these are the number of models. And if you want to further monitor on a larger basis, then additional what sort of measurements are been required are also been interpreted. And once this has been carried out, then after we will determine on the basis of creep and fatigue life that how the temperature should be kept with during the course of RAMs, or as a monitoring, you will continuously see that what is the stress levels or the temperature level that you need to keep within that component. So you need to then after monitor and keep the temperature of that component within that level.
For this, you need a shutdown of a boiler actually, because to take these parameters online is not, no tools available there. So you have to take a shutdown, and then you have to take the manual readings. You have to put it in model that yeah, last time thickness was this and this time thickness is this. Okay, many cases we have seen this is not the case for boiler. The sudden tube matter temperatures are increasing and then immediately tube fail within 6 hours to 8 hours. Then how you are calculating that RUL, because that is not nowhere related, which you told that okay, these pressure temperatures can suddenly change while about the tube leakage. Okay, and one tube leakage can impact on second on the same day. So that is not a theory which is working from the studios for the temperature, the pressure of that particular tube. Because we are not maintaining pressure and temperature of the boiler. That is a massive task to do. So here, every time I'm asking this, every time I'm or that they say, but the raw data which is required to calculate that, there. Why a question always I mark on the model that when you don't have the data, you don't know that how this system can change the minutes, and how these models are being trained to identify the geometry that you like of the data. Numbers where you don't have data. Have you ever given a model and have you predicted 90% or 95% accuracy that what has been? Similarly, in the turbine you shown the image where you are saying that the last that bottom plate will go forward or so. We have no sensor to measure bottom casing certain things. You have to open complete turbine in 5 years that you see the last bottom casing top, you have to lift bottom casing upper and outer both up. Then only you can measure the thickness, and then you have to measure the vacuum and monitor. These are some things which we need the input data, real data. That is it a real-time model, or after 5 years when turbine will be open, then you are going to see the thickness and then you will tell us that the turbine is going to fail or is going to fail. So this happens only 5 years. Capital shutdown, we normally take it. Have you seen these cases? This is
Archon could hear that. I don't know if Archon is able to hear, but specifically coming to the point, you were talking about tubes and tube leakages, and what we are talking is about the headers and the thick wall components. As regards the turbine, I think Archon could explain to you, but I would just beg to bring your attention to that topic, the tube leakages and what you are speaking, and the thick wall, the impact on the thick wall components and joints are two different topics which we are talking about here.
So do you have any mechanism to measure these things which you are telling? The headers and the joints of boiler?
See, so the headers and all the thick wall components, there are boilers which have measurements, and if we need to implement FMS, then it is necessary to have the measurements installed. So that is our take.
Okay, thank you.
You're welcome.
as well as the digital twin. Really, we are thankful to you, and just like questions and queries, definitely there will be, because this is the very new technology.
Yes, okay.
Everyone is searching the solution. Definitely, it is in the maturing stage. That's why there will be questions and doubts also. With this, if there are any questions, you may contact to Mr. Ribolo and Mr. Gore. And I think it will be fruitful for us.
Yes,
Now,
most welcome. Yes.
Proceed for the next presentation of JSW Jharsuguda, and I request Mr. Avinash Ujwal to present it. Thank you. Thank you.
Good afternoon. So hope nobody is sleeping now, huh? These days, boxes are being used earlier to hide the tummy. People, those who speaks here are with lot of tummies in power plant. So now we don't need this. So now you see the people are using stages and that all, right? So this is giving trouble to me already. So in whole day, in a lot of presentation, very good presentations I am seeing from morning. I have few questions which I asked. And so digitalization, always digital have two parts. Okay, one is the projects which we are looking for and we are producing. The second most important aspect, I am not listening from morning. What is more important, the digital projects or a digital mindset? Correct. Okay. So for me, when I always say the most important thing is digital mindset, your people, okay, the workforce which is there into your plant must have a digital mindset, that is called digitalization, right? So these projects may be 50, maybe 100, depends on industry to industry. It may be in steel, it may be in power, it may be on aluminum or anywhere else. The only thing which we need to change is the mindset of people. So I always say this is a digital mindset which needs to be changed. People should think digitally, right? So whatever we are doing, if we can convert this from analog or human behavior to digital, it is a digitalization. So it may be very small, it may be very big, The only thing which I am seeing in all those presentations is monitoring, right? So all those things are monitoring. We are monitoring this, we are monitoring that, we are monitoring this, we are monitoring this. In morning, I told your output, the outcome, it should be very clear. So there are two parts. One is monitoring, which is very critical, very important in all the plants and all the aspects. And the second part also I will include, this will be analytics, right? So while doing monitoring, only seeing dashboards will not help us. So morning I told you I have a lot of meters, but that is not giving me a use. So we will focus more on this analytical part also. And I will go through very quickly because I have a lot of projects to talk about. And all those details, if you require project by project, you can contact me later stages or you can contact me via Katre Sahab. So I will go very quickly with the ideas, right? And idea details, if you require, then we will go ahead and we will see. Because I have some live, dashboards with now. We can operate it from here also. Okay, I don't have a dashboard which is there. Or we work on Google actually many times. So first, let me introduce my company. So I am representing here JSW BPSL. We are a 3.5 MTPA steel plant. Okay, so our specialization is steel. So you can see it's a 3.5 MTPA plant, which is having power plant of 506 megawatt CPP and all DRI, blast furnace, pellet plant, center plant, all those steel sections we have. The power one I will talk about. In power, you can see we have 3 units of 130 megawatt, where the control system, you please note it down, because we have Siemens S7400 for turbine control, and we have Ovation for boilers, right? It is for 3 into 130. Then next we have 40 megawatt one unit, 60 megawatt unit, and 2 into 8 megawatt units. Here you can see I have ABB, then I have Max DNA, then I have Yokoga CS3000. I have steel section with me where I have, Honeywell, I have Emerson Delta V, So I can say from a C&I perspective, I have all types of control system in one plant. So all those DCS which are there available in market, I have all of them. Okay. So now the biggest challenge for us is to integrate, because you have Yokogawa, Honeywell, Ovation, Siemens, all of them are working on their own platform. Okay. So first challenge is to come together on one platform. This is a big thing which needs to be done on first port of digitalization, because you have to gather data on a single platform to analyze, right? So that is what we have done. We have taken all those data on one platform and we considered and we made a MIS for that. All right. So you are going faster than me, huh? Okay. Go back. I have this. Give me a presentation here. Going up, down or not? No. Okay, these are some awards and recognition which we got for our plant. You can move it from there if it is there. Okay, no problem. So this is all about control system. Next slide. So this is one dashboard entirely made 100% from 0 to 100. This is made by JSW VPSL only. Okay, no vendor, no EM, nothing. And this is based on completely on Python. Okay, we made this using Excel, VB and Python. This is in-house building, 100%, no OEM or nothing. Okay. So here you can see in this dashboards, we have all those features which are being used by our maintenance team. Okay. So we have a very good feature here. You can see that SMPs, troubleshooting, list, search, even complete instrument list is attached with that. So if a maintenance engineer immediately wants what is the detail of that particular transmitter or that particular instrument, he has to go there, search, and immediately complete list will open. I can show you, it is with me. So it will open all those details which are there with the instruments. Okay, so while ordering, if you want it, it's a very handy tool actually. I will not talk about very big. So you just put the transmitter tag and search it, and all the specifications you will get, the range, type, and everything which is required to purchase, right? Similarly, you see the troubleshoot, all types of instrument list is there. You have to go, there is a selection column. You have to select, it's a pressure switch. Okay, select the pressure switch. It will show you the all the causes of failure. That what a pressure switch can fail, a spring can fail, or a diaphragm can fail, or whatever the possible causes is we have seen in all those years are already there. As you will select a cause, that why it has been failed, what is the type of failure, then it will show you the corrective actions also. All right, what needs to be checked and what not need to be checked. Immediately you will see and it will show you what to do. Okay, so this is one tool which I have given to my team. You need not to call me and ask what to do. Okay, so even a GT, even in a less experienced guy for 2-3 years, he will go and open this dashboard. Immediately will put the actual scenario that my transmitter is not giving correct reading, or my transmitter is giving over reading, or it is giving under rating, or whatever it is. He has to just open, put the select the cause, and immediately course of action will be there, and he can take immediate action depending on that. Okay, so what this benefit has given to me, अब मैं रात में आराम से सो सकता हूँ. Right? If I go to some marriage, I can attend that marriage function, need not to call, go side में और 1 घंटा उसको समझाना है, ये पेपर खोलना है, ये करना है, ये करना है. Okay, so this is one digitalization tool for me. Similarly, all those protocols of all those years, whenever we check, even after a shutdown or even a startup, or all those signed protocols, we scanned and we uploaded in this. Okay, so if I want to check, as Siemens has told, this year performance, and I want to compare it to the last year performance, correct? So either I have to rush to the files, I have to collect all the data as open and see and this all. I don't want this. Okay, in my team, just go to that column, select the year, select the file you want, the protocol name, and it will be in front of you. Okay, so need not to call me, need not call to some senior people or some middle level people of department and ask them that kya value tha us saal mein. Okay, even operation guy can see, even anybody can see, because all those documents are there into one dashboard. And next, you can see incident and RCS. So whatever RCA reports we made, okay, we have a 10-step or 11-step, 11D technique for RCA in my department and my team. So we do all RCAs whenever something has failed or something we, got something. So these RCA reports are already being sent into this particular dashboard. You have to go and see the failure and you select, and complete RCA report will be in front of you, so that if a similar failure is happening again, okay, My team need not to call and need not to search for something. Immediately see that this type of failure is already happened there, or what was the root cause. This may be the root cause this time also, right? So this is to view. So this is the one small tool which we made in-house by using some Python coding. If you want the codes, I have codes, and complete everything you want, I can give it to you. It's not, for sale. It is to distribution. Next, please. This is one more dashboard. This is again 100% in-house. Okay. Only made by one person who has asked questions from, I think, NTPC, Ranjit Singh. He has made this. Why we made this actually? Not for monitoring or display. Right. So the second part, which I told you, analytics. Right. Using this dashboard, what we are doing, what I ask them every time is, after 1 year, what you want as a material for the next financial year, just give me the list today. Okay. What you want on April 2024, give me list today. How they can give. Okay. So this is called digitalization for me. So we have a dashboard there, immediately you go, select the financial year, select the area even. You can select boiler, you can select turbine, you can select even, the packages, BFP, or you can select, any CEP or anything. And you will see in this complete year, how many spares we have used. Right? In ash handling area, in ESP area, how many spares we have used. A complete list will be given, a complete price will be given, that for this complete year in ESP area, you have spent 50 lakhs rupees. And these 50 lakhs rupees contains these much seal kits, these much diaper, whatever, the spares items will be there. You can select from item, you can select from code, you can select from area, you can select from asset, you can select from area, boiler, turbine, whatever you want. All those selections are there into the dashboard. Okay, so this is helping me, this is helping my team, and this is helping everyone in my team. So this is one tool which helps me and whole my team and my boss also. So if he asks me that what is the budget required for next year, I can tell him based on last 2-3 years. Okay, so these are some handy tools, very basic tools, don't require very much expertise, but it is very useful in day-to-day life. Okay, because everyone is not using those big things which needed for, big meetings and boss meetings. So these are the things which are required at ground level. So these things should be there, or I think these are very useful. So these are some digitalization tool which we invented, and it is very useful to us. You can opt for. This is dashboard 3, which I told you, the procurement. Correct. So whenever my boss calls me and say me, you have taken budget of almost 10 crores this year. Okay. What is the situation today? Because this is again one question which needs to be asked from top management, because they only ask for budgets. Right. So budget and performance are two things which increases my salary and your salary too. So here, this dashboards give me the total budget, how much is in OPEX, how much is in CAPEX, correct? How much is in priority 1, priority 2, and priority 3. We have 3 priorities to procure items. Priority 1, which is critical and immediately required, without that system will not work. Priority 2, it may be, it may not be. I have some, quantity, but still I need some quantity for an year-to-year basis, right? So these are priority 2 and priority 3. Today, how many PRs are being done? How many PRs are being converted into PO? And how many materials are about to come in this month? If you get in an email report, will be you happy or not? Okay, your boss will also be happy, will not ask you. Every month, every week, if an automatic report will go that this is the current scenario of my procurement, status of department, or maybe power plant hold. Okay, so this is also made by in-house team. Okay, so these are some basic models which we can start and which we can implement, and very useful actually in day-to-day life. Okay, because by this, what we do is we do analysis that in last year, maximum problem in my plant is in which area, So this is what analysis we do with these dashboards, that, okay, 70% of the job or the manpower is went for ESP area. Now in ESP area where? So we see that pneumatic cylinder seal fails, it's a big item to fail every time. So we see that, okay, almost 25,000 man hours are spent on this particular task. The rest all is in the 25 to 30% only. Then where to focus? Right? So immediately our focus goes on ESP and that pneumatic seals, how to prevent that. So that is next step. So when we do analytics on these tools, these small tools can help you to guide where to focus and where need not to focus, right? So every time doing PM in boiler and turbine, it may not help you because they are not going to fail easily. What will fail, we are focusing. Okay, so this is how these analytic boards should happen and what we should do actually with these dashboards. Only I told you in morning, we have a lot of meters in Audi. Almost everywhere we can see a meter in Audi. But the driver who is driving is 10th pass or 12th pass only. He's not a technocrat, he is not an MBA. Have you ever seen a driver of Audi MBA or something like? No. So it doesn't know what that meter means. You know? So this is the problem. We have all those tools in front of us, very big screen, MIS, and we don't know what to do with that. So that is not proper digitalization actually. So this digitalization means the analytical part is more important. Once we do the monitoring, once we made all those tools, how to use them is very important. Okay. So these are some basic tools which we made for ourselves. It is not for power industries or not for maybe other industries. These are for our department. Okay. This is for me. This is for my team and this is for my boss even. Correct? Okay, next. This is one very good example again for digitalization. All of you may have this issue that our ash handling lines are failing frequently. As CPP guys may have more, right? So we say that repetitive failures. Ash line once, leakage, rotated, again leakage, rotated, again leakage, again leakage, again leakage, again leakage. Do you have a record? You see, data is there. We know that every time it is failing. Do we have a record? If I will ask you that immediately, your boss will ask, कौन सा band सबसे ज़्यादा fail होता है? Where is the maximum problem you are facing in ash handling lines? We have nothing, but we have a graphics there in DCS. Okay. So here you can see these colors are represented numbers. Okay. This red means failure more than 10. This orange means maybe greater than 5. This blue means greater than 2. And if nothing is failing, then it will be green. You know. So this is a simple graphics made in DCS. It is not a very big tool. No analytics, no machine learning, kuch nahi lagaya. It's a simple graphics where we put a DCS program, right? If this band fails, you just give a +1 count, nothing else, right? By seeing this, we analyze that where is the maximum failure in these lines. Then you do analysis that, yeah, why this is failing in this particular zone, right? So this is not a big tool. You can make it just by tomorrow with any of your team member. Just go and make it. So these are the things which we call digitalization, right? Not very big, we are thinking. Okay, I don't want to become Elon Musk. No, very truly. So I want to do these things which are helping me in day-to-day meetings and day-to-day activities, correct? So this is helping us in finding the actual S-line leakages. And it is a ₹0 job. When I am free, I'll make this. When you are free, you can make it in 5 minutes. And it will help you, your operational team, as well as your leadership roles, leaders. That, yeah, why we are failing here, it is okay. Now, the one big problem with CPP team told me, in morning also I was talking to Katre sir, when I entered from IPP to CPP, okay, I saw an entire different scenario. I came from a plant which is #1 in Asia. Okay, we got all those awards in continuous 3 years for #1 plant in Asia, not in India. And suddenly entered into a CPP which is entirely new. No automation, nothing. Everything is manual, which I asked you. Variation of 50 megawatt, 70 megawatt, and we are damaging our boilers like anything. Because this is the requirement of industry. IPP and CPP has 2 different requirements, which they told arc furnace is suddenly down, arc furnace is suddenly up. There is a deviation of 50 megawatt. How to cater that? So they have said that, okay, manually we do and we damage our boilers. Similarly, they told me that we are doing the same practices from years and years. Then what I did is, okay, I'll resolve this issue by a small method, right? 50 megawatt in 1 boiler or 2 boilers is very dangerous, right? How many boilers I have? 10. Okay, give it 5, 5, 5, 5, 5, 5. 5 can be done. In any boiler, 5 megawatt can be done. It is not dangerous for that boiler. Okay, so what I did is, I put auto, correct, and given a single set point to all those 10 boilers, right? So when I want a 50 megawatt depth, I enter 50 megawatt, it will automatically go to 555 to all 10, and 5 will cater, and boilers are not getting damages now, right? So this is a level of automation which you need, right? A very simple, 50 to somebody, ये वही वाला बात हो गया, बॉस ने आके आपको इतना बड़ा गट्ठा एक साथ पकड़ा दिया 20 फाइल का, you have to do it tomorrow. You will trip. वो 20 उधर ही रहेगा, कल आपका पेट दर्द हो जाएगा, आप छुट्टी चले जाओगे, घर में कुछ अर्जेंसी हो जाएगा, मम्मी का तबीयत खराब हो जाएगा, पापा का हो जाएगा. This is कुछ नहीं हो सकता, because the capacity is capacity, that boiler is not having a capacity of decrease or increase of 50 megawatt, even 800 megawatt boiler cannot. Right? So here you have to find a way. That is what we do. Right? So immediately I thought that I will do one thing. I will give 5 megawatt to all of them, so that if 3 megawatt they will catch, right? Still it is 30 megawatt support to my STL and baki hum log jo import se chalate hain, right? So that is one thing. And meanwhile, what we are doing using this digitalization or using automation, if I will say, we will save our boilers. Correct? So this is one more thing you can see here. This is a auto operation looplet where you only have to give the megawatt as a set point and you automatically give all those things. So this is one unit, one CPP in this zone, which is running in fully auto, 100% auto. Okay, I went to some places, I will not name them out, but I found this problem. So you can take a help and you can go through this. This will help you a lot actually. Next, please. So one more very small tool. Okay, we have a legal register to define that my boiler date of inspection is this and expiry is this, because we have a lot of boilers, 24 boilers. We may be 506 megawatt, but we have 24 boilers. Okay, you have only 8. So you have to note down 8. We have to note down 24 for expiry. You know, because industry specific, right? So to remember that which one is coming or which one is not coming, then suddenly my legal wala will come and tell, "Aapka date expire ho gaya. Plant band karo, ye karo, wo karo." Okay. So what is the best way to do this in a digital technique? We made one graphics. Okay, it is in auto. When my boiler last certification is being done, we will put it there and we will start a counter. And these you can see number of days pending for certification. It's a very small tool. Now, this is on screen in graphics. You need not to remember, you need not to put into registers, and no mistakes it will do. Okay, it is an automation. It will automatically give an alert 1 month before that, yes, now boiler inspection is about to come. Okay, every day it will send mail to me, to my boss, as well as to mechanical HOD, right? So this is what a small digitalization tool which can be used in day-to-day life. All right, next please. Okay, so I heard Katre Saab in morning that we have a Windows XP system now in OTS and we are very much, troubled with this. Now we want upgradation, and if they will go to some OEM, they will ask them 2 crores, 3 crores, 4 crores. The same thing I faced, right? In one of my plant, they say me, this is a system which is old. Now you have to come to 2010. Correct? I asked them, this is 2010. What about 2012? After 2 years, you will come and will say 2012. Again, upgrade. Then you will come in 2015. Again, you will say, now it is obsolete. Now it is 2015. Please take a new. So every 3 years, I have to pay you crores and crores. Right? Okay, I made a statement. I made a financial statement. It comes to 150 crores for upgradation. Right? I went to my boss, chief executive of the company. I presented that I need 150 crores budget in CNI. He told me we'll bring new CNI head. You please go home. So 150 crores to CNI, They will give 1.5 crores, it's okay. That too very different, very difficult to get. And 150 crores, as soon as I asked, he told me, go home, either you change department to HR. Then what to do? So I told him that if the system will not work, because this is about to obsolete now, and we will not get spares and nothing. So you see, top masters are there. Bosses are always top masters. He told me, I don't know. I can give you 1 crore. Bring it as a new system in 1 crore. Now I told her, okay, from tomorrow onwards, I will update my resume. Because 150 crores is not that possible to convert into 1 crore. Okay, we are not, Bhagwan, Vishnu and Brahma, so we'll give a tathastu and it will happen. Okay, so that is not digitalization. So now you have to think innovative actually. This is what we call digitalization. So Khatri Saab told me, and immediately I just put it as a note that when I will present, then I will tell him. Okay, this thing I already shared into that group that day when we were meeting. So this is one thing. You have to search for the solutions which are there nearby. Okay, I went into IT industry. Immediately after boss told me 1 crore, I asked them, what you do? Because they have systems actually, lot of systems. We have very few. 10 system hota hai, aapka OPS nahi to 15 hota hai, utna hi hota hai. But they have lot of systems which are working on that. Then they come up with a solution which they told, why you not go for virtualization? Now for power plant people, virtualization is nothing. We don't know and we never thought of. I told, okay, just give me insights. What is this? Kya hota hai virtualization? Okay. Then he told me, you will feel that you are working on Windows XP. You will not get an insight that you are working on Windows 10 or Windows 11 or Windows 12 or Windows 20, whenever it is, right? So you will see it as a Windows XP system. I will show you at the Windows XP जो इतने साल से कर रहे हो वैसा का वैसे रहेगा पूरा. पीछे मैं क्या करूंगा तुमको देखने की जरूरत नहीं. Okay, मेरा problem ये था कि Windows XP is the problem. So if it can be resolved, then it is okay. Okay, so there is one thing which is available that is called virtualization. Okay, you can put some servers, virtual servers, and they will create an image in any PC. आपका घर का PC में भी डाल देगा, and you will see this as a OWS. Right? And this costed us 38 lakhs. You understand? 38 lakhs. So my account is happy now. And my boss is very happy. Then he told, and he took a credit that I pushed you, that's why you did it. That's true. Right? So the same thing in digitalization, you have to push yourself. Just think beyond. Actually, this is what I always say to my team. Don't restrict yourself to here or power industry or steel industry or IT industry or India or outside. So this is what I learned from these, all those things, that there are things available in markets. This is one option. You can go for virtualization. Okay, next please. Connection is close. Okay. Okay, there is another method which we call migration. Okay. So these two already, identified by me and executed by those agencies. Don't worry, I can give all those details and it is very cost effective. The migration team, what they do is they will change all the licenses, all the settings, everything, even the MAC address. Okay, which is very, different thing for power plant engineers. But we CNA, we have to understand that our server fails and then we have to go to our vendor to ask for a new key because MAC address is changed, right? So every time we have to tag to our DCS engineer, oh, USA se karke deta hai, India mein to kuch nahi. So what they will do, they will take this MAC address, they will take all licenses, everything, they will migrate on a new system. Entirely new system, which may be Windows 10, Windows 11, Windows 12, Windows 20, whatever it is. They will copy each and every % of data or settings from your Windows XP PC and they will convert it into the 2010, 2012, 2015. Just go to your OEM and say, we don't require your services now. That's why they are, enemies of me. वो बोलते हैं जब आपको कभी प्रॉब्लम होगा तो हम सब छुट्टी पे चले जाएंगे. Okay, so these are some small digitalization tools which every plant needs, and these are executed by me myself. That's I can say confidently that this will work. So by using this, you can save a lot of cost to your company. Okay, so you can try this on a smaller scale. You can put 50% of this, 50% you can upgrade, and then you can see if it is okay, satisfactory, then need not to go for upgradation every time, right? Okay, these are some credentials. They have implemented these virtualization and that all, and you can add my previous plant name here also. Okay, so these are credentials. If you want, then you can check, and I have taken the personal demo of all those things. Next. So this is virtual network. So I will not go in detail. You can just search it out. Please, next. Okay, now I'm giving some project ideas, which I worked for all those years. Okay, quickly gone through all those projects because time is a limitation, and digital, we have to see the timings. Khatre Saab is continuously looking towards me. All right. So first you can see turbine vibration for predictive analysis. Right. The next, these are pain points of power plant actually. Next is prediction of boiler tube failure, which I recently asked from some of the presenter. Fire alerts by thermal image sensing. Okay. I will give a small brief of these projects, and details you can ask me later. Then it is field checklist and boots on ground. Okay. Then it's digital twin of key assets of key components like big one, VFPs, turbines, and that all. Why these are advantages, I will tell. Then ash bulker management, digital helmet or smart glass, then access management, operational alert on WhatsApp as well as on Telegram. The code I already shared with all of them. Real-time optimization of ESP, IoT-based electrical equipment monitoring, and the last is digital data capture of field instruments. Okay, I'll go very quickly with this. Okay, because of the time limitation, and further details we can ask. Next. So this is prediction of turbine vibration. You have to see expectation from tool. So when I develop a tool, when I thought a tool, I always write down the expectations. What is expected from this particular tool or digitalization tool? Okay, you can see operations, they have a requirement of pattern analysis with respect to process parameters, right? This is requirement from operations, not from CNI. Then they want time series prediction. They should know that after 8 hours, my vibration will be high so that I can immediately start some corrective action right now, right? From TMD, turbine maintenance, because they are also a stakeholder in turbine, right? They are owners of turbine. If you will go and touch, they will object. So this is prediction of premature failure of turbine internals, which he was showing in that, right? So they are more concerned about physical damage. So operation is concerned more about process-wise damage and process improvements or something like that, right? So these are the outcomes which you have to take from the active users, right? As being CNI, we are not going to run this plant. We are not going to run turbine. We are not going to run boilers, right? So when developing this, you have to call all those stakeholders and ask them frequently what you want. Okay, note them down. Okay, so here you can see a small graphic representation that unit data you are having in VMS, okay, vibration monitoring system. From there, you have to take via maybe AWS, Alchemy, whatever you want. There are a lot of tools available in market to convert the data actually. Okay, now from there, data ingestion is coming. Now you see there's a Hive or whatever you want to use. Okay, there are tools available into Amazon. They are used as a Google, or there are a lot of things available right now for prediction and data analysis. From there, you can see it's a SQL server. Then a dashboard can be developed on BI. Okay, Power BI. So Power BI is a tool for monitoring, which from morning we are seeing. Okay, so this is how the data process will come. So this is the data process flow. Next. Okay, next. So what are model deliveries, right? Expectation versus model delivery. What my model will deliver, okay? And with what accuracy, right? Okay. So this is completed. Okay, all those details are with me. If you want, I can share. The next one is metal temperature accession, which is the biggest pain point of thermal power plants. If somebody can tell me that your boiler is about to tube leak in evening or tomorrow morning or after 3 days, correct? Can we prevent? Yes, we can try, right? Or the second thing, if we cannot try, then we can plan a shutdown, right? It will not be sudden failure. So there is a tool which you have to do analysis. I have done my analysis, and very surprisingly, I'm telling you, I was very surprised when I was looking for this data analysis. Can you think what is giving me a prior indication of failure? What is the component? You will say boiler pressures, boiler temperatures. All these experts will say pressure, temperature, how you are running, DM makeup, water chemistry, all those parameters. Okay. Have you ever seen the data? Okay. I took 450 parameters for cross correlation. Okay. One by one, we have maintained the cross correlation. We found the correlation matrix, and highest number we got is 0.92 to 0.95 is with cold air and hot air damper. Can you think of? Okay. So that's why I tell nobody is expert. Data is an expert. You do your analysis, just find the correlations. I was also not thinking. My operation head was all never think of. My O&M head has also not think of. But my data is continuously telling me that whenever indication 6 to 8 hours earlier, that my cold air and hot air positions are increasing and changing. And immediately after that, 6 hours or 8 hours, my boiler tube metal temperature accession has happened. Okay. So when we talk about analysis and data, just be open. You can't think which parameter is correlated with what. Okay. So this is a CBI job to do. Sab pe shak karna hai. Okay. Every parameter you have to doubt. So this is something which I did, and you can just see this. This is the analytics. So do analytics, correlate with the parameters, and then find out what is the actual reason. Don't go with, perceptions and exercises. These are not okay. You can pour some experience into it while selecting the parameters, but openly do this, because data, what it says, we know. Okay. So just believe on the data. So this is one thing which I told you. We have developed this completely. We have seen all those cases we have studied. You can make some 4 or 5 cases. One may be this, one may be something else, right? So the best method is to know the temperatures of boiler tubes, right? A very small suggestion with good practices, we always say, just cut a pocket of 1 inch or 2 inch on your boiler insulation on top. Sir, you can do this. Cut a 1 inch or 2 inch pocket in insulation. Okay. Give somebody a temperature gun and daily send him there and just monitor the temperature. because whenever that orifice choke is at the bottom, the temperature of that particular tube will rise. It will not rise 3 or 4 days back, or temperatures or pressure will not go up. Immediately it will shoot. In the evening you will get a tube leakage. So every day if you will find it, then yesterday if it was 400 and today it is 420 or 430, or today it is day after tomorrow it is 450 or 470, then you can easily identify that this tube is having some issue. Either tap it on a lower load, or whatever you want to do as a corrective action, you can take a corrective action and you can prevent a failure. Right? So this is how things will work actually. Okay, fire alert by CCTV camera. The motto was, my boss told that lot of security as well as fire people we have to put in plant to see, because plant is very big, as your plant is also very big. How many people we can send? Because a fire can happen in gate, a fire can happen near to CHP, a fire can happen somewhere else, a fire can be happen in anywhere in the plant where the area may be manned or may not be. Right? So what we can do is a digitalization. Okay, no problem. Put CCTV cameras, put video analytics on that, and immediately as soon as it will catches fire or smoke, it will give you an alert that this particular zone is catch the fire. You immediately go and do the firefighting. Correct? Okay, you can see. Go ahead. So there are the tools available. Okay, I work with some Canadian company on this, right? EO Cortex. You can find out net. So they have $150 or $140 odd licenses for each model. So they have all those models you can see. So this is one, that fire one. We trained the model and my camera immediately detects the fire and it will alert you. This is the second, number of persons entering and number of persons leaving the office. My boss told, I don't want a punching machine. Everybody should go and show their face for attendance, not required. Whenever he enters, automatically attendance should punch. And when he leave, time should be there. कितने बार आया गया ये भी मुझे पता चल जाना चाहिए. So there are tools available, right? You put a CCTV camera and it will give you कितने बार हम लोग आए और नाम फोटो के साथ में कितने बजे आया, कितने बजे गया. वो आपसे झूठ बोल भी नहीं सकता है. Right? So students, you are in danger now. Katreji has already decided. Okay, next. So field checking digitalization, the thing was that we were observing that few people are not going actually to field, the operators. Okay, this is for operators. And they are putting false checklists that it is okay. How to check that? We cannot, because what a checklist he has filled and he will give you in ship last that this is the field and everything is okay. Now how to trust? Right? So this is why this is being made. You have to go there at field, you have to scan a code, then it will give you that, yeah, now you open the form and you fill it. Okay. And to prevent human errors, you have to remove all those entry points manually. Give the selection tabs. Select yes or no, abnormal. If abnormal, then only remarks will open, otherwise it will not open. Right? So this is one basic tool which is required for field monitoring as well as for this operator ka thoda sa screw tightness. So this is how he has to scan a barcode, then it will be open. You can just use a normal Google, right? You have Google Forms, just scan and open it. It will open only and you can make a Google design by your own, and barcode also it is available. So it's a free tool you can make by your own. Port on all those machines, right? So this is one tool. Next. Okay, 3D view of boiler expansion, right? So what it told that they have a load cell. So that is for weight measurement. But how to expand the measurement of boiler expansion, because boiler when it goes it expanded, maybe in any other direction, right? So this, by using some laser tools, you can make this digitize, right? You have to put 3 laser sensors in one side, and if you want better measurement, you can put it in 4 sides. So in any 3D, movement is there or expansion is there for how much mm, you can directly identify using this, right? So it will take 3 sensors. It will not be 1, because we are working in 3 dimensions, because boiler will expand like this also and this also, right? So from 0, how much boiler is expanding, you can find by using this particular tool. Okay, this is one more. Next. Okay, so all this is only summary for complete. Next. Go ahead. Okay, so this is ash bulker. That is one scenario which was asked. When ash bulker will move from there, okay, it create congestion on roads. बहुत सारा ash bulker आके खड़ा हो जाता है ash collect करने के लिए, right? Now road is congested and boss is shouting. So what we can do that, okay, एक बल्कर जब वहां से चलेगा तो उसका मुझे इन्फॉर्मेशन मिलेगा कि उसको मेरे को इन कराना है या नहीं कराना है. Should it allow him to enter or not? Okay. So if I can get the information of that S bulker that it is at 40 kilometers or 30 kilometers or 20 and earlier one is already there, then I can put a access management. No, it will not enter into plant. Meanwhile, this will go away. So this is one tool. You can put some RFID on those or GPS tracking on those bulkers. Well, it will move from there. You will know that after 20 minutes, it is about to reach. And meanwhile, in 20 minutes, if it will be filled, then it will go and it will come. Okay. So you can remove this congestion and you can resolve this particular issue by using a small tool. This is a digitalization tool, correct? You can do RFID as well as GPS tracking, which can be used. Okay. This is very useful for cement industry and power plants because of ash, right? Next. Okay. This is digital and, smart helmet. In this one helmet, or you can say a safety goggle, which is having a camera and one screen on your, glasses, right? So your glass corner will work as a TV, as a monitor. So by sitting on remote, maybe in India, maybe outside, okay, you just go in front of that machine which is failed or the problem where it is, right? You just give me a call, correct? You just go in front of that. I will see with this camera that you have to focus that on this particular zone problem is there. Okay. In that window, I will be there continuously on second side. And I can open documents from my seat. I can open PDF, I can open drawings, I can open drawings and zoom it out that, okay, next you see this. While seeing this picture in that particular glass, you will find like a TV. It is designed like this, okay? So you'll find like a TV and you see that this problem is there. And similarly, I can track one by one, and I can guide you there because I am also seeing everything what you are doing, okay? And my voice is there with you and I can tell you with drawings also. So this is one thing which is very useful. Okay, not costing very high, 5 to 6 lakhs only. You can purchase 1 or 2 pieces and you can enjoy this. Okay, because we have big plants. Okay, these tools are very much handy and very much useful. You can take help from OEMs. Okay, he is sitting in Germany. We are in a critical issue. Now help come here and resolve the issue will take time. So immediately, if you have the smart glass, right? So all those details, offers and everything I have, if you want videos, everything you can take. Next. Now, this is very small thing. Operation alerts on WhatsApp or Telegram. WhatsApp, we leave it out because of the security reasons. And then we went for Telegram. Okay. So we linked it with MIS because my DCS data is already in MIS. Correct. With MIS, I made a SQL query that whenever my overrange will occur or underrange will occur or bad quality will happen, immediately it will go on a dashboard and a Telegram. A message will come to concerned persons that this thing is failure, bad value, or whatever the value is there, it will come out. Right? So this you can make in-house. Code is already with your boss. I already forwarded them the codings. Right? So you young guys can develop this. Your students can develop this. Okay? There are only 2 APKs. Just go with the APK file and security settings you have to do. You have to write a SQL query to extract data from MIS and send it to WhatsApp or Telegram. Okay? Make a group and send all of them. So whenever there is a discrepancy in any data, immediately it will go on Telegram. So your boss may know, operation may know, or anybody else that yes, this has failed. No need to go to operation and raise a notification. Correct? Okay, next. So this is visitor management. There is a problem in power plants, confined space work. Right? So when we work into boiler furnaces, there is a small manhole. People may have gone inside, but doesn't have come out. नाइट में आप लोग चले गए, कुछ पता नहीं है कितना अंदर लोग है नहीं है, मैनुअल डोर क्लोज कर दिया, लाइट अप भी कर दिया. Because you have data, how many persons entered. आप भी चले गए, वो मूवीज में देखते हैं ना हम लोग, एक बच्चा रह जाता है लास्ट में स्कूल में. This is the same thing. If we have this management there, then it will alert you in evening that one is missing. Maybe bacha, maybe teacher, whoever it is. Right? So this is for confined space. You have to put a camera. It will count number of persons entry, number of persons exit. And in final count, you will see that number of counts is 0. The difference amount, it is okay. If it is +1 or +2, then there is a problem. Right? So this is one tool which can be used with video analytics. No need to give a lot of cost in this. And safety will be very happy. Next. Okay, this is optimization of ESP, where you can just tune it. This is an automation job, more in digitalization front. Secondary and primary current of ESP, right? By looking that current, we can say my ESP performance is okay or not. We can revise the settings, correct? This is what we do. By seeing the current, we change our wrapping frequency as well as all other currents and voltages, correct? So you can do one thing, you just put an algorithm, track continuously those currents, right? When current is decreasing or when current is increasing, just put a logic of DCS to corrective action. So this you can do right now, okay, by going this. Tomorrow you can develop this. This is a digitalization tool to have. Okay, I give you the current you take as an input, and based on that current, put an algorithm or a logic you make. If it is decreasing or if it is increasing, we know the reason and what corrective action needs to be taken. Immediately you take, or alert or an alarm you can give. This is the problem, because we take ESP as a PLC and DCS never communicates with ESP. We say it is an electrical man's job, and we CNI never take this ESP responsibilities, right? So now this is not the case, because emission can shut down the plant. So it may be CNI, it may be electrical, it may be operation. Okay, everyone will be punished. So this is a small tool, communicate it with, okay, make a current as an input and put those algorithms and correction on that, right? Okay, this is latest development, which is not in-house. You have to talk to your vendors, ABB or whoever it is. So now they have a robot to inspect your, transformers. And they have online DG analyzers for IIoT, right? These are IIoT enabled devices. You can talk to them. So whenever you get a shutdown of, unit, this can enter in live transformer. The robot will enter from the drain pipe and it will inspect all the internal conditions of your transformers and give you a report. Second thing is, these online DG analyzers can take 3 inputs, and they will take inputs and they will give you, right, whatever the parameters are required for transformer healthiness. So electrical guy may know, okay, why degasser is there. So this is DG, online DG analysis, and IIoT, they will give you a dashboard, they will give you life, they will give you the conditions, everything what you told in monitoring. So all those things are available. So these tools are available nowadays to check transformer healthiness, right? Online. Next. Next. Okay, so this is all about from me. So quick questionnaire if time allows, or otherwise big questionnaire, I know. So you can make a list of them and you can send it to me. Yeah, please. Accuracy more than 95%. No, it doesn't require people. It requires data. When you do normalization, you know the process of analytics. When we take data and then we go for data normalization. That is one step of, if they have read it. So that is called data normalization. While doing the normalization, when we just make correlations and cross correlations, then you will find out some data is having 0 cross correlations. So there is a matrix I have, but if you want it, I will show it to you. It is my laptop. So you have to make a correlation matrix where the data which is irrelevant, okay, less than 0.55 or less than 0.45 or correlation with all those parameters, you need to remove it. That is of no use. It may be very important, seems people can think in their mind that this is very important hoga, but while checking this correlation matrix, you will find it is having 0.25 or 0.35 of ratio of correlation with all those parameters, right? It is a matrix X by X. So one parameter will be cross correlated with all those parameters. You can take 400, you can take 300, you can take 200. Okay. So you check no relevance of that data with any of that. That is of no use for us. Okay. So in data normalization, we filter out. Okay. After that cross correlation, we find out that what are the 40 parameters or 30 parameters which are actually cross correlated, and then we do analysis on that. Right? And it may vary actually condition to condition. You have to train your models on different types of failure cases. Okay, one may be oil well in turbine, because which is very common, oil well. So oil well comes suddenly, and oil well is having 0.4x frequency component is going up from 1x. Okay, this is something very technical. So 1x to 0.4x, we can easily relate that there is an oil well. So sir metal. So this is how this condition. If this 0.4x will happen, then which bearing will show what? 50 megawatt. We have a blast furnace. Don't worry. We have arc furnaces 5. So 2 can go simultaneously down. We have 3.5 MT plant also. Don't worry. This happens. But we have 10 boilers. You can give it 5. If you are, you have to understand your concept actually. This is one example which I took for my plant. You have to think in your plant way that how you can prevent your boilers. Okay, because your boiler tube leakage is more harmful than 2 or 3 megawatt export. You have to understand. This is what the digitalization do. If you will pour 3-4 megawatt or 5 megawatt even export extra, which is not being paid to you, no problem. But one tube leakage, 2 or 3 days of boiler down, as well as lot of manpower to correct that, okay, and that generation down. You have to calculate very wisely this. So okay, 3-4 megawatt you can give, no problem. Right? Import to करना है, थोड़ा पैसा लग जाएगा, क्या फर्क पड़ने वाला? But you can save your boilers. So this is the concept actually. Optimization. Correct? The method of optimization. Okay, thank you.
Thank you, Avinash, for giving good insight about this digitalization and digital mindset. Now we are left with 6 presentation. Yeah, it is it is very Herculean task to complete that one. And I think it is the time of tea break. We will have tea break of 5 minutes. Is it okay? And again, we'll come back and we will try to accommodate two. No, sir. Yeah, 2, 3. Yeah, we will try to accommodate. Yeah. Yeah, we and definitely we will try to accommodate most of the presentation, and for that we have to be fast teach. Okay, thank you. Enjoy the tea.
Recording stopped.
बट ये तो जीमेल से ही मैंने सेंड किया था, जीमेल पे ही है मेरे, साइज इज नॉट द इशू। Yeah. Good evening, all. I'm Sandeep from Adani Power Raigarh, and I'm working in Operation Efficiency Department. Also, I'm looking after technical trainings, and I'm site lead for analytics initiatives. So I'll be presenting you some of the initiatives taken at Adani Power. Yeah. Okay. Good evening again. And today I joined along with my colleagues, Mr. Ankit and Mr. Vikesh. Now I'll be moving towards the presentation. Next slide, please. So these are the contents we'll be going through today. First, we'll go through DISA, that is Business Process Transformation at Adani. Then we'll go through Chetna, which is Safety Process Transformation. Then I'll introduce with PIMS. Then APM, which is Asset Performance Management. Next is our APC and DSM monitoring software and dashboard. The next is Beacon. That initiative is for analytics. With this initiative, we are developing in-house talent for digital initiatives and analytics. Next. So this is DISA. This we started our digital journey way back in 2014. So the name of project is DISA. This is basically BPT, Business Process Transformation. With this, we started our digital journey. In this, throughout the process, I'll summarize in brief. We transformed all our O&M processes. We redefined our KPIs, and all parameters have been converted to the measurable parameters. Like there was no generalized practices. Everything was formulated and things were being monitored across all the Adani sites. That helped us in improving our process compliance, as well as we have uniform practices across all the other Adani sites. Now, how this was digital. So with this initiative, we migrated our process like RCA, FMEA, all our maintenance processes with SAP module. All the records are well maintained in SAP only. Now, with advancement, we are having mobile application also. With mobile application, you can apply for permit. You can monitor all the applied permits and status, everything you can monitor with your mobile as well. So this was about Disha. Next. And within Disha, we developed certain tools also, like for coal management, we developed coal pileage monitoring tool. Then to improve our, to optimize our fuel consumption, we developed fuel oil consumption tool. That was towards the optimization of fuel oil consumption, and we've achieved significant results with all these tools. Okay. Yeah, this is about Raigarh. For Raigarh, we have concluded 37 sustenance meetings so far. And other units are, obviously, they started at 2014 or 15 way back. They are also maintaining well. All the compliances are more than 90% as on date. So this is about safety. Safety cannot be left behind when we are proceeding for digital initiatives. So we opted for Chetna initiative. That was more than process, that was cultural transformation. We trained our people, we trained our process as well. And we transformed all our safety things into, again, in the form of KPIs, and certain committees were formed. Process were again defined. And with this, we developed GenSuite application as well. So this is the digital integration of our Chetna process. With this tool, you can log all your concerns, you can report anything regarding safety, and you can have all the statistics with this single tool that is available in your mobile application as well. Next. Okay, this is about PIMS. PIMS is nothing but Plant Information Management System. Here we are having all the process data, real-time process data of our all Adani plants. I can, from Raigarh also, I can monitor each and every parameters which are operating at Mundra. So that is very useful for management to take any call or to monitor anything. That is helpful for us also. Being the MIS and efficiency person, I have to monitor a specific coal consumption all the time. I have to change the coal planning accordingly. So I use this with my handset as well. So this is very useful, and also this is integrated with Excel. We are having Excel add-in for this. So I can download any range of data, any amount of data at any point of time. Everything is available from remote also. We need not to be connected in our office network. From remote also, we can access all the data. Next. Okay, this is the latest one, APM, Asset Performance Management. So few modules are implemented, few are under implementation. So this is how the failure occurs. So if we'll delay to predict the failure, your cost of repair will definitely increase. You can see there in the graph. So you have to land somewhere in between. Before the failure, you have to predict. That is what APM is doing. With APM, we are having all our major parameters from BTG. BOP area, we are not integrating it. So all the major parameters of BTG is available in this single dashboard. Again, all the Adani units, any anomaly or any abnormality in parameter is detected by the tool, and alert message will be generated to concerned persons. Process to process concerned persons are also defined. So they'll be getting the alert message. On few incidents from HO also, our team is there, monitoring team is there. They can also monitor. and they can also track the performance and parameter trends. So this is about APM. APM mostly comes with the integrated tool of RCM as well. So in next phase, we'll be proceeding for RCM. Next. Okay, maybe few of you are aware of this PiVision software. Here we are having all our energy consumption data. So we are using it for our APC reporting, all our export import data, and then our DSM monitoring also we are doing with this software. This is as per the updated logic of DSM. So with this, we are having dashboard, we can monitor as well as we can download the reports, and in Excel form, we can use it for whatever the purpose we want to use it. Next. If anybody wants more insight, you can ask me anytime. I'm just quickly rushing through the slides. Okay, this is Project Beacon, initiative for data analytics. What Adani thought is, there are a lot of agencies that will support you towards the analytics and they'll help you to have different tools. But what we thought is, we'll develop our in-house talent for analytics as well. So people with having the good statistics acumen and good command over analytics were sorted through the screening process, and they were then selected for Project Beacon. All across the Adani, 34 people were selected from different sites. 2-3 representatives were selected, and they have gone through the training and workshop as well for 4 months. Okay, after that, we've been able to achieve certain results. Okay, this is analytics maturity curve. So here you can see we were landing a year back, and now what we are doing will be coming in upcoming slides. Next. So now we have fully functional team of Beacon at 2 sites, that is Tiroda and Kawai, and we are having site leads at all the sites. And I'm also the proud member of Beacon team, and I'm leading the initiatives at Raigarh. Okay, this is the R-shoot detection through video analytics. That is 100% in-house implementation. No support from any external agency. That is completely developed and designed by our engineers, typical O&M engineers like you people. They were not aware of the analytics a year back. Now they are doing all this. So they collected thousands of images and did model training, everything, image sampling, everything was done in-house only. Now it is the functional project. Next. Okay, there are a lot of initiatives ongoing, but I'll be sharing only the ones which are done by the O&M engineers. That is only useful for we people, because at organization level, we are developing a lot of things with different vendors and different agencies. Okay, this is the AI-based safety surveillance. As you can see, the person is going over the bulker for opening the lead, right? So earlier there was no detection mechanism. This is AI-based again. We installed a camera, that is simple CCTV camera. With certain programming, we've been able to track whether any person is available on the platform or not. If any person is there in the platform, we'll start disseminating the message that you have to wear your safety gears, otherwise you cannot go over the bulkers. Next. Okay, this is the virtual safety assistant. This is also the in-house development only. Here you can ask any question regarding safety. That was developed at our Raipur plant. So you can ask any question regarding safety, and this kiosk will answer your questions. So anybody, any visitor who is coming inside the plant may ask what is the speed limit inside this plant. So it will respond as 30 km/h. So that is how it works. Next. Okay, this is again motion sensor based. whenever anybody enters in the switchgear room, that's a critical area. It will again disseminate the safety instruction, what all the instruction he has to follow. Instructions will be passed on to the person in local language as well. Next. Yeah, safety message, safety instruction will be disseminated, sir, with the help of speakers. Audio will come up. Okay. So this is towards the traffic traffic safety. So that is available in many of the places. So it will be monitoring your vehicle speed. Alert will be displayed in screen itself, and also it will capture image and details of your vehicle. Same details will be forwarded to the concerned person, like the safety head or security head, and you'll be getting the mail that you have been penalized for this. Next. Okay, this is again regarding the bulkers. So camera views the lead of bunker, then it guides. Target lines are provided basically on the system. Based on that, bulker operators will be guided to park in a particular place. Earlier, all the things were communicated and done manually. Now it is semi-automated, we can say. Next. Okay. As sir has mentioned in previous presentation, like the in-house development and the small efforts, that helps you a lot. This is the one of the example for similar effort. This is the training dashboard, typical training dashboard, where all the data are updated on real-time basis. As soon as you'll complete your training, your data will be updated here and it will reflect to you. It is accessible to everybody inside the plant or HODs as well. There are different dashboards for employees, HODs and section heads. So you can access the dashboard according to your need. All the data are populated here. This is just one of the dashboard. In similar manner, we developed dashboard for all the coal analytics, coal related, all historical data is available in a single location. Then SHR, APC, all MIS parameters are available with the dashboard. So you can play with the dashboard that is available and accessible to the concerned person. And every information since inception is available with the dashboard. Next. Yeah, that's all. Any questions from audience? Okay, thank you. Thanks for your patience.
Thank you, Sandeep ji, for nice presentation. and giving insight about your initiatives taken in the digitalization analytics. Really, they are very helpful for us, especially which are done in safety. Safety really, it is a very good tool. Now, I invite Sharvin Misra from Adani Kawai to give the presentation. Arvindji, please.
Yeah, sir, good evening. My colleague, Mr. Neeraj Sharma will present the presentations. Neeraj, please continue.
Good evening, all. Sir, can you share our presentation or enable us to share the presentation?
Yeah. He's making you the host here, please. Yeah, it is visible now.
Okay, sir. So, good evening, all. I am Neeraj Sharma from Adani Power Limited, Kawai. It is basically a 2 into 660 megawatt thermal power plant situated at Kawai, Bara district of Rajasthan. Now, our project background is the supercritical boiler of a thermal power plant is a confined space. During annual maintenance activity, around 400 to 500 workers make entry and exit in boiler for 24 into 7 hours throughout 25 to 30 days maintenance period. Boiler have multiple manholes at multiple elevation to get entry and exit. So safety is a very big challenge for the workers working inside the boiler. In current safety practices, most of the power plants or power or any other industries uses the manually entry exit register outside the confined space. Due to the manual entry process, there are certain drawbacks of manual entry register system in confined space monitoring. As there are multiple manuals for manpower entry and exit, there is a possibility of missing entries. If anyone misses the entries, then the 100% data accuracy can't be maintained. In manual system, worker in and out status at any instant is not possible because the consolidated data is not available due to the manual entry exit register system. Also, if worker is staying inside confined space for a long time, can't be noticed. The odd hours manpower monitoring is also not possible in existing manual entry register system. So in case of any incident, we need accurate data availability regarding number of workers inside boiler. In order to eliminate this manual problem, we thought of using some digital technology for a solution. For this, we have developed IoT RFID based boiler entry exit register system, which is an automated solution for keeping online record of entry exit system of the workers. This system enables safety personnel and engineer in charge to keep track of workers inside the boiler on round the clock basis. Here is the schematic. Any person who is subjected to work inside the boiler is provided with a safety helmet having a unique RFID tag pasted inside or outside helmet. Every manhole of boiler is installed with a pair of RFID reader. One is installed outside the manhole and one is installed inside the boiler as mentioned in schematic. The RFID reader emits RF signal to passive UHF RFID tags in order to energize and respond back to the reader. The UHF tag data read by the reader, then communicated to the embedded controller through the Modbus communication. This controller basically stores the data of manpower movement. Then embedded controller has inbuilt Wi-Fi logic building capability, also the data storage capability. Through Wi-Fi, embedded controller establishes a connection at cloud via internet. The cloud server receives the tag data and uses this data for data rearrangement, data analysis. An algorithm is prepared on cloud which decides the entry and exit of a worker depending on time stamping by inside and outside reader. Server data is arranged in desired table like RFID tag, worker ID, worker name, agency name, etc. This data can be accessed from anywhere through a website xaees.com via secure user ID and password on mobile application as well as desktop application. The IoT RFID based boiler entry exit register system consists following elements: UHF RFID tag, reader, embedded controller, power supply, dashboard, mobile phone, and some salient features are there. All RFID tags are usable for next AOH and COH. System is designed for 8 entry exit manholes or gates and can be expandable to any number of gates. System will register entry exit time 24 into 7 hours. System is interfaced to desktop computer or mobile with various customized reports like employee master report, employee entry exit report, employee available inside the boiler report, particular employee movement, and alert report. Here is the comparison in pre and post system implementation. How will we identify the manpower movement in boiler? Earlier, it was done by manual logbook. After that, it is basically tracked by a RFID reader who can monitor the manpower entry exit in boiler. Earlier, safety supervisor was placed at each and every manhole. Now, all authorized persons who are given the access can track manpower movement on mobile phone or desktop. Odd hours remote monitoring. Earlier, it was not possible. Now it is possible. Consolidated data availability on fingertips. In manual system, it was not possible. Now it is possible. At any instance, number of persons inside the boiler can be monitored. Earlier, it was not possible. The alert is given if the manpower is staying for a long time inside the boiler. Yes, there is definitely a safety enhancement through the technology intervention. Any human intervention? Yes, earlier in manual system, a supervisor was placed for logging the data. Now there is no intervention required. System practical implementation during AOH and COH at APL Kawai. The workers details are mapped on UHF. These tags are pasted either inside or outside the helmet, as helmets is a compulsory PPE. We have developed the magnetic mounting frame arrangement for RFID installation inside and outside the manhole for easy installation. Here are some mounting arrangement pics inside and outside. This is the embedded controller arrangement outside the manhole. Total 8 manholes are covered in present system. So these there are some web portal and variety of reports are available on which we can track the manpower movement. It is the dashboard where total active users and inside user count are available. Live alerts are also available if manpower is staying more than for last more than 6 hours inside the boiler. This is the report inside employee report. This is in and out movement at every second. This is the live alert report where we can track. We can see that the employee Devinder Singh was staying for more than 6 hours. So we can easily identify who is inside for a long time. The system advantages: 100% track of manpower movement, Entry exit of person from any gate is tracked, as there are number of manholes. So person can make entry from one gate and he can exit from another gate. So we can easily track from where he gets entry and exit. Record can be generated person wise, agency wise, day wise, and period wise. Consolidated data report for manpower movement is available at any point of time. Auto alerts are available if person is staying inside the confined space for longer time. No human intervention required. Fully integrated system. Cloud database system with proper report and real-time monitoring. Manpower movement in confined space during odd hours. And safety enhancement is all observed during past 2 AOH and COH at our side. Thank you for this is from our side. If anybody have any questions, then we are open.
Neeraj, you can answer the presentation.
Yes, sir.
Recording in progress.
Yeah, I have two just queries actually. The one is how you ensure that the labor are not exchanging those helmets because RFID is fixed. So once they enter into coil chambers, they remove their helmets. While coming out, they exchanges them. The second is how to ensure that these labors are charging those RFIDs on. Okay, so these two things which we see as a problem in this particular project. So how you handle both of those?
Sir, at the starting of any AOH or COH maintenance, we designate our safety personals and call the safety supervisors of each and every agencies. And in our presence, we paste these tags inside the helmet and then distribute to each and every labor or worker. Now it is not possible, sir, to control if anybody just swap their helmets. It is basically a manual restriction and disciplinary part basically. If they basically exchange and somebody is inside and something happens, then the count is there. So we can track easily that somebody is inside. That thing we can ensure, but it is totally the disciplinary part. If somebody exchanges their helmet, it's beyond control, sir. However, we before starting the AOH or COH or any task, we just go for toolbox talk where we provide some instructions to their safety supervisors and the workers who are basically subjected to work inside the boiler. So this is in our hands, sir, completely. Time to time toolbox is there. And pardon, sir, second question I actually couldn't listen.
These RFID, actually, we procure all the RFID and distribute to the agencies manpower who will really work inside. That list we are getting from the agency. And this RFID is not chargeable actually. At Kawai, we are procuring the total RFID.
Just one question. If somebody is just wearing the helmet which is not having RFID and going inside, how he is prevented?
Sir, only the workers who are subjected to work inside the boiler, they actually gets distributed the tax, and we pays the helmet tax on the helmet. So that is only a control. We actually
go inside the boiler, and you have given them fitted with the fire. But a person who is not authorized to go inside the boiler, but having the similar helmet inside without any tag. Is there any, somebody is there to control, or usually what happens with this RFID based access control, that some flap gate or something, that type of thing is there. When they detect the authorization, then the gate is open and the person is allowed to pass. But in this case, within the boiler gate, it is not possible to put the flap gate. There has to be some mechanism to detect whether the person is authorized or not.
Sir, as per factory law, we have to actually depute one supervisor outside the gate. Basically, whenever these tags comes in the periphery of RFID reader, it generates one sound, sir, basically. If that sound is not generated, then he can stop that manpower movement.
Some mechanism sort of thing is not possible, then so that person is standing there, be able to say.
No, that's a good idea. Actually, we are in the next phase. Actually, we are thinking of putting some barrier outside using this RFID also. That's the next phase of development. And at present, whatever Neeraj said, that the concern supervisor, as per the sound, controlling the manpower. At present, it is manual. But yes, we can go for it. We can put some mechanism of putting a barrier or some message. Definitely, that is the next phase of development.
Thank you. Any other? Yeah, thank you to all the presenters as well as the participants. Now we are at the end of the today's session, or today's workshop, and there is concluding session. For concluding session, I would request to come to dais Hori sir, Ujjwal ji, Rajiv ji, and Sandeep ji. Sandeep ji, please do come. Yeah, yeah. Very special. Today we learned so many things from each other and synergize ourselves. There were, as per plan, there were 12 presentations, but due to time constraints, we could complete only 8. And other presentations are with us, and it will be shared to you. With due permission of the presenters, please. And Now I would like to request Mr. Rajiv ji to come on the dais and say something about this project.
So, good evening, again, my seniors, my friends and colleagues. Today's presentation was really informative. As a, we are just started this digitalization now, but this is a journey and there is a long way to go. Definitely, we have to, if we want to change something drastically, then digitalization is the only way, and today's world, today's time is the for digitalization. एक हमें हमेशा कोशिश करना चाहिए. एक कहावत जस्ट याद आ रहा है सर कि मंजिल मिलेंगी भटक कर ही सही, मंजिल मिलेंगी भटक कर ही सही, गुमराह तो वो है जो घर से निकले ही नहीं. So let us start this journey, and I hope we will definitely achieve our goal. Thank you, sir.
Thank you, Rajiv ji, for your kind words. Now I will request to Sandeep ji to please come and say something.
Thank you, Katre sir. Thanks for inviting me, and thanks to all the participants for joining here. It's been really very informative and wonderful session throughout the day. Exchange of thoughts, exchange of ideas, and exchange of initiative has been great. Earlier also I joined workshops here, but regarding today's workshop, it's been the most useful session because digital and analytical initiatives are need of the hour, and definitely we need to sharpen our skills on these fronts also. And certain few students have also joined. So for you, my message will be digital and analytical, because you'll have to do this only in future, because somehow we people have been working for last 10, 12 years. Few are working for 20 years. Now we are struggling to develop skills, but you have time to develop, be developed on these skills and be ready for future. Thank you. Thanks to all.
Thank you, Sandeep ji. Now I will request Avinash ji to say about the program, please.
So nobody is sleeping. That is one good thing. The second, I spoke a lot today. The only thing which I want to say is, हम सब ने बोला हम लोग अभी अपना अपना घर जाएंगे, आप अपने अपने घर जाएंगे. If things are not changing, then these types of workshops are not working at all. So I'll always suggest that don't think for very big projects. Okay, start with a small one. When it will be completed, you will have a very good, feeling, and it will motivate you to make a larger one. Okay, because many projects I see it is being done with OEMs, we only pay. That will not give you a satisfaction. Okay, so start with small things which can give you a self-motivation. Once complete a small project and be happy. Okay, and see that once we start from zero scratch and we complete it to 100%, it gives a motivation. All right. So bigger projects done by other experts or other parties or OEMs will not give you a satisfaction. Okay, they will tell you some, they will not tell you something, right? So real excellence they will catch by their own. So my suggestion to you is only try one or two small projects, which will be very useful in terms of digitalization for you, for your team, for your department or your organization. Okay, give some fruitful results. That is what we want to change. Okay, so we are here to change your mindset. We don't want to change organizations because they are very big things and they will change slowly in a pace. So what we want is, we want even 10 or 20% here, if they will change their digital mindset from tomorrow onwards, right? So this workshop is a highly successful workshop actually. Okay, so with these words, I'll complete my thoughts for the day. Okay, thank you so much.
Thank you, Avinash ji. Now I would like to request for concluding remarks to Munish Johri sir, please.
Thank you, Katre ji. Today is a great day for us, particularly
I am very fond of these new technologies and adoption of these things in the plant or any other area of our life. We had very good presentations, small initiatives to bigger one, like the flexible operations and other things. So we had a lot of learning in these presentations. पहले कहा जाता था कि कंप्यूटर को आप जैसा आप डेटा डालोगे वैसा आपको आउटपुट मिलेगा, बट आजकल इतना एडवांस हो गया है कि आप उसमें कुछ भी डालिए, कुछ ना कुछ यूजफुल इंफॉर्मेशन तो निकल के आ ही जाएगी. एंड दैट इज द ब्यूटी ऑफ our analytics, AI and all those things. जैसा कि अभी उज्जवल जी ने बोला, don't think of any big project because conceiving those big projects requires a lot of efforts, money and those things. Think of small projects which you can do, but channelize those small projects which can be integrated in future into a bigger this thing. Like one presentation was there, you can have the equipment identification with, say, a barcode. You can expand it to the spare part list of that equipment. Once the barcode is scanned, you will have the list of the spares, manufacturers and all those. You can further expand it with integrating it with the stores, whether those spares are available. You can further expand it by requisitioning the spares. If you are doing a maintenance and you require some item out of it, you can simply requisition from the site and the things will be delivered to you. So, I mean, we can have a small initiatives, a small beginning, and it can be expanded into any bigger things. So that is the beauty of this thing. A modular approach if we will have, then, and जब हमको छोटा-छोटा सा modules हम बनाएंगे, उसको successfully करेंगे, we will also feel happy, and it will motivate us to do for the bigger things. Of course, bigger projects like our flexible operations, एक integrated bigger projects की एक अलग जरूरत है, जो कि हमको लेना ही है और हम करते रहेंगे different areas में. Turbine systems का, vibration monitoring systems और health monitoring systems और all those things. लेकिन कुछ छोटे-छोटे initiatives जो कि हमारा work space में जो हमारा work culture है हमारा, या हमारा अपना convenience है, या हमारे workers का convenience है, उसको जो increase करता है. जैसे कि जो अभी last presentation था, एकदम बहुत, I mean, कहना चाहिए प्राइमरी नेचर का वो है, बट जो उससे हम अचीव कर रहे हैं, ये बहुत बड़ा प्रॉब्लम है कि कंफाइंड एरिया में हम जो लोग जा रहे हैं, हम उनका अकाउंट मेंटेन कर सकें कि मतलब एट द एंड ऑफ अ डे everybody who has gone inside has come out or not, or if because the equipment's boiler is such a big area nowadays, if in a bigger units, अगर कोई कहीं पे trapped है तो will not be knowing, and everybody will go in the evening, and person who needs some attention there may not be getting that help immediately, and it can lead to some unfortunate incidents. So it's a very small initiative, but it's a very important initiative. So such things we can keep on doing, and it will help us. And today's workshop is giving us insight into this. Various stations are doing many things in their own domains. We have to integrate and learn from each other. A good platform, I understand, of head of C&I is of the plant in the vicinity is there. So that is a very good networking opportunities you are having. So I hope this today's workshop is of help to all of you. So let us now, I mean, we are at the end of the workshop. So thank you for to all the participants who have come from different stations to this side, and those who have connected from remote locations and presented the presentations from the remote locations. Thank you.
Thank you, sir. Really, just our speakers told us that, and what we experienced today, no one is zero and no one is 100. We are all in the journey and we are embarking our paths. And in this journey, our collaboration is must. And this is one of the endeavor in that. This is the starting. This workshop is starting to network ourselves and synergize ourselves. Now, all the presentations, the contact links, contact numbers of all the participants will be shared with you. Then, on your own interest, you may contact with each other. Definitely, it will be helpful for us. And at this, I would like to say that on behalf of JIPT or Jindal Power Limited, in every month we are organizing the workshop, function-wise workshop. Last month's workshop was on coal. This month was on this C&I digitalization. Next month, we are planning for the boiler tube leakages, boiler tube failures. First, in that fashion, we'll go ahead and we will form the community of ourselves, which will be helpful for our proud fraternity. Now, at the end, I would like to give token of love to all the presenters. Thank you. Now I request Johri sir to give a token of love to Raigarh team. Raigarh वाले आ जाइए please. इनको और भी दे दीजिए. Finally आना पड़ा. Thank you, sir. Give us up. Thank you. Now I request Johri sir to give the or token of love to Avinashi. Aji. Then to Rajiv ji, please. Aji. Really, I am thankful to all of you for making success to this workshop, especially to our PGDC students. Definitely, this is very much useful for them because they at the starting they have given the broader aspects of the power plant or what will be going after that. And I'm thankful to our JIPT team also, JIPT, as well as our guest house team, our HR department for their cooperation for making success of this organization. And at the last or not least, to all the participants who encouraged us to go ahead and organize such type of workshops in future also. Really, I am thankful to all of you. Thank you. Thank you very much.
Thank you. Thank you very much.
Extremely sorry, this program could not be completed without the support of our online presenters as well as the participants. Really, how this more than the participants were online, and they definitely encouraged us, and their supports is always required to us. Really, I'm thankful to them, as well as the presenters who are online. And really, I felt very sorry for the presenters who cannot be accommodated in 2Z workshop. Just like GE Exact Space and this EP Genco Singareni, we could not accommodate them today due to time constraints. And really, I'm obliged for it. And their presentations will be shared with all of you. By tomorrow, all the presentations will be uploaded in our website, and it will be available for a week. You can go through it. And apart it, we will try to send you the presenters also. Thank you. Thank you very much.
Thank you. Thank you very much.
Thank you, sir.
Yeah, we will group portal.